Welcome, everybody. Tonight we have an interesting discussion. I have with me is Mike from TikTok. What's your YouTube?
Hey,
What's your TikTok name, Mike? Mike.
hey, it's Mike Scribner 369, dude.
Yeah, it's hey TikTok. Give me an A. Give it. Let's
Hey,
hey.
come on,
There you go. And then we have George Lewis, who's a high school student who is writing a paper about flat Earth. What is it about?
Well, it's about the flat Earth model, what like how it corroborates with observation and just what how it corroborates with observation and yeah,
Okay.
it's about like
general understanding. You're just trying to get a
yes,
grasp
sir.
on what's going on.
I will admit it is more of an argumentative paper, and I am on the side of actually I should have just given a little bit of background. I aspire to go into the field of astronomy, and I have a basic I've been educated in this subject, and I know that I know your views on that probably, but I just want to tell you what I've been taught and see what you kind of have to say about all of that, and see like how you contradict it with your research and your expertise.
Sure. So with the heliocentric model, do you know how fast the Earth is spinning, allegedly?
I don't know the exact number, actually.
It's 1,000 miles an hour at the equator. All right. Do you know
sounds about right.
How fast we're orbiting the sun?
The sun, well, one rotation per year.
Yeah, so. But so you know how many miles per hour that allegedly is?
I do not.
66,600 miles per hour. And then the sun is also allegedly flying through space at close to 500,000 miles per hour. So we're going in, those are just three directions, and none of them are linear. They're all curved. So if you're in a car going 100 miles an hour on a perfectly smooth road and you had a dinner plate filled with water, no problem. But if that car sped up or slowed down or took the slightest turn, what's going to happen to that water?
Well, it's gonna fall off. And that actually brings me to my my first point, I guess, because what I've been taught is that we aren't really accelerating or anything. It's still a constant velocity.
So that's actually not true. They say that we're going around the sun, and it's
elliptical, right?
Elliptical. We're speeding up and slowing down, speeding up. So we are going, and then acceleration. If the Earth is spinning at a perfect speed, that's cool. But when you go off of that linear path, that is the same as acceleration. That's the same as acceleration. So you're driving in a car, you got a dinner plate filled with water, no problem. That car takes the slightest turn at the same speed. That water is gonna be pushed off the plate. So just to give you an idea, we're on a ball surrounded by water, surrounded by air that is moving in 4 different directions at once through space. So this is the hypersonic sled track, and it's going to go by at Mach 8.6. Can't even see it. You can't even fathom that speed. You have to believe we're going 10 times faster than that around the sun and 100 times faster than that around the chasing the sun. And all of these directions are curves, or we're taking curves in all of them while spinning. But then when we go out and we look at reality, this is what we observe. We observe this. Perfectly stationary. Nothing is moving. Right? So you were taught, I don't even like using the word taught, you were told a lot of things. You have to look for the evidence. Well, how did they determine this? How did they determine how far the sun is, the radius of the Earth, the speeds? How did they determine it? Where's the proof? Mike, jump in anytime you want.
Well, it's deceptive for me. I'm sure you've heard of Aristophanes, the sticks and stones, the shadows, all that. They're just manipulated experiments. They're just experiments that don't prove either. If you take what you were taught with Aristophanes, that works with a distant sun, okay, on a spherical Earth, but it can also apply to a level plane with a local sun. So it's not proving either model, so therefore it's not really, it's just a nothing experiment. It's just words and there's nothing scientific method. The process is not followed, in any way to prove that. The same with, if we talk about like the Foucault's pendulum, it's not the Earth's motion that's putting this in. If no one, it has to be a mechanical force, or obviously someone starts it. There has to be a force that starts the motion, and then they just track. Well, that's not the Earth's motion. That's not, that again is just an experiment that isn't proving anything.
So may I say something? So what you were kind of saying earlier with all of the directions that we're going. You were talking about the Earth's spinning and like how we would fly off it. Are you talking about like the centripetal force of the Earth?
Yeah, that's what should happen.
Well, yeah. Well, what I was taught in school is that the centripetal force is not really anywhere near the force of gravity that is being exerted on us. I think.
Yeah,
I think that's the word. So that because the centripetal force is like it's not stronger than the gravitational force that's acting on us, so that's why we stay onto the Earth. And as for like the experiments being manipulated, I don't really have anything to like anything right now with me to say anything against.
It's a lot to take in. David, I think you're muted. David.
Oh. I am muted. You're right. I like doing that once in a while. So on flat Earth, when we talk about gravity, so there's Newtonian gravity, which is the apple fell on his head. Thank God there wasn't a kid there with a helium balloon at the same time that let it go, because then he'd be scratching his head, not knowing what to think. And they've changed that to Einsteinian bending of warping of space-time now. So they can't make up their mind. That gravity is just an unproven theory. And when you have a... Go ahead. You said something?
I wouldn't really say... Well, what do you mean by unproven? Because
they have no proof of gravity. There's nothing that proves gravity. It's a theory, and the theory is so bad that 96% of it doesn't work. They're like, well, the gravitational model doesn't work. Unless there's dark matter and dark energy. No one's ever seen it. No one's ever observed it. But there has to be 96% more matter out there that we just can't see, or the model doesn't work. So therefore, there's dark matter and dark energy. So they made it up. So if I owed you $100, I could pay you back $4 and say we're even, because the 96 are dark dollars. They're there. You can't see them, but you have them. You'd have to accept that. It's the same thing.
Yeah, so I've never really, honestly I don't really know much about dark matter and
nobody
stuff.
does, because it's made up.
Yeah.
Nobody does.
Nobody, yeah.
Well, yeah.
Nobody does.
Yeah. You're not alone, bud.
Yeah. So while we're in gravity, and I know that you want to go all over the place, but let's just do a couple of things right here. So I'm holding a balloon here, and it's hanging down allegedly because of gravity, right? It's not even blown up. It's not even blown up. So the question I have is, what holds the air to the Earth? Because we can't have high pressure. Nowhere in a lab or in nature or anywhere can anyone demonstrate gas adjacent to a low pressure or no pressure system like space without a physical container.
Well, gravity is what is supposedly holding all
so
that.
Let's think about that. So gravity is holding the air down, but water molecules in the air, clouds, which are heavier than air, they float. What about gravity?
Well, I would say that's a density thing.
The water molecules are more dense than the dry air molecules.
They are. Oh, well.
There's
you
no
know?
excuse other than electrostatics, and we can get into that in a minute. But this balloon is hanging down. So we have 1G. It's not really stretching the rubber. It's just kind of hanging there. Like here's a balloon. It's just hanging. It's not going up. It's going down, allegedly because of gravity. And the rubber is not really stretching. It's just holding its own. But if I turned up the gravity dial to 10 times, you think the balloon would stretch a little bit? Probably. Right? 10 times the gravity
Well,
pulling on this, it might stretch the rubber.
not re- not really. So so the thing is with gravity, the reason why at least what I was taught, the reason why it's like it's the same reason why you're not like getting crushed into a like why we don't get crushed by the gravity is because the earth is exerting a force on us that uh like and the fact that I'm sorry if this is like if I'm all over the place, but the force that you have that you're exerting on it by holding it is
Like
not
negating
it's
gravity.
overcoming the force of gravity. So
Yeah, I'm holding
really,
it up. But what I'm saying is if the gravity, I turn the gravity up, the gravity would pull on this rubber to the point where it would be able to stretch the rubber. Even though I'm holding my hand up there, I'm ignoring the gravity. All right. And so if I turn the gravity up 100 times, it would stretch it. Right. That's not a theory or anything. That's just a fact. Right.
Yeah.
If I hung a 1 ounce weight on here, it really wouldn't do much. But if I hung a 16-ounce weight, it would pull it, or 3 pounds, it would stretch it. So gravity, a stronger gravity can do that. But if I put air in this balloon, what is the air trying to do? It's trying to escape in every direction, including up. The air is stronger than the gravity. It's stretching the rubber. Air will violently fill the available space everywhere except in space for some reason. Gases, like if I said, hey, let's have a barbecue, go get some propane, but I hate containers. Don't get a container. Just bring the propane. Could you do it? No, you can't. Because the propane will violently fill the available space until it's equalized. Open up a soda can, psh, equalizes instantly. Every gas wants to equalize. We have storms because high pressure and low pressure are adjacent to each other, and the air will rush into the low pressure. So,
well, sorry.
Go ahead.
Can I? So, well, with the balloon thing, the rubber actually is it's compressing itself. So that's what's pushing the air out. It's not really.
So we'll take it one step farther.
And I know what I get where you're trying to say. Like air does fill space, but it because the Earth's gravity is the only force that's acting on that air in space. It's like that's not really how it like works. I guess like I said, I'm just in high school. I don't really understand like the.
Well, here's the thing. You were born with God-given common sense, and we're not asking you to recite what you were told, in the textbooks that are meant to just control you. We're asking you to use your God-given common sense. And if gravity can hold the air down and the void of space, the vacuum, the low pressure, the no pressure of space, the air isn't going to violently fill it, well, then we should be able to do a demonstration. Let's say I had a lucite box and I sucked all the air out of it. So I have a vacuum of no pressure, and I have a valve on the bottom of it. If I opened it up, what's going to happen? The air is going to violently fill it. It's going to fill up with air instantly, pulling that air or rushing that air up and away from gravity. I can drink with a straw. With the weak low pressure system of my mouth and lungs, I can pull water and air up and away from gravity. How come space can't pull it up and away?
With how strong space is and the vacuum of space, and you have gravity keeping trillions of tons of water, oceans to the ball. Yet, like you just said, the weak vacuum of my lungs, I can suck the water right off, right from the ground away from gravity. Yet the extreme vacuum of space can't do that. To me, I thought that was an easy, a real common sense way to, I guess, explain that. That I don't know, that hit home with me a lot when I first heard that and thought about that. I was like, man, I never thought of it like that, and it is crazy
Uh,
the difference, you know, in pressure again, and such a minute force like my lungs is able to suck water off, yet the vacuum of space can't.
well, I think we're getting well. That's not really the definition of vacuum that I've been given. Vacuum just means absence of stuff.
No pressure.
Like,
Well, no pressure, it would still equalize. Like David was saying, if you have something with no pressure and you were to involve, you know, you introduce pressure, it equalizes. It's going to fill the room. It's, you know, so sucking off like a, you know, however you want to describe it, the same way it would equalize. So I guess you would say the space wouldn't suck off the water, but it would equalize.
The air would rush into space because air pressure needs a container. If you have a container, you know, that if you have, you know, when you have your propane tank, if it's half full, you got thin gas at the top, thicker gas, then liquid gas at the bottom. There's a pressure gradient. But put a hole anywhere in that tank, all of that gas is gonna, you know, it's all gonna turn into gas, and it's gonna equalize instantaneously and violently. But for some reason, it doesn't happen in space. For some reason, gas in space, instead of filling the available space, collapses upon itself and creates suns and stars, which are bigger than suns, even though they don't look bigger than suns. Well, that's because they're far away, we're told. But you have burning balls of gas in a space vacuum. Again, this breaks all the laws of thermodynamics. It's just absolute impossible, but they say it's possible. Therefore, you just have to believe it because somebody said it. Some guy in a lab coat said it. So there's a thing called electrostatics. Everything. Go ahead. Go ahead.
Actually, I had I can't I've got questions prepared for you guys.
Let's do it.
Actually, so yeah, I just like, all right, well, like number one is I can see that the sun sets. I can see it go over what I call the horizon. And so why does the sun set? Why does it go down under the horizon? Why can I see it go under the horizon?
Yeah, does it go down, or is it just going away?
I've seen it go. I've watched the sunset at sea level on the beach.
Yeah,
and it goes down under the horizon.
Well, that's what you think you're seeing, but once you understand how the sun works, and how the sun works, how our eyes work, and what we're actually seeing. So I'm going to show them the kitchen right here. So here we have a little model of I got my kitchen counter. We'll call it the flat Earth, and this line is the path of the sun, and I'm moving the sun along this line. I'm viewing it from a celestial raised position at the same height. Now, this could be mountains. This could be a cloud deck, just the atmospheric deck of opacity. We're above it. We never go below it. Now, I have a terrestrial camera on the counter on the other end watching the same thing from the other side, and let's see what it looks like. This is what it looks like. It looks like it's going down. And this, which looks to be at eye level now, it looks like it's going below it, but it's really not. This is the same thing you saw from another direction. And if I zoom in even more, this is a level line, but your brain is telling you that it's almost going straight down. And the sun is just following the path. And when we compare it to a real sun, the sun is just going away, and it is following that path. It's following that path.
Well, like I said, I saw it at sea level, which is
this is sea level.
You said
I don't know if he can see it. I think it's blocking the.
I can see it because you said like the bottles were mountains.
Well,
my example is.
Wait, what are you seeing?
So I'm looking. I'm on a beach, looking out into the ocean. It's at sea level, so there's no change in elevation. It's at elevation 0, and I saw the sun go down under the horizon. No mountains.
So let's show you this first, okay? So here we have our grid. This is how we see, and everything goes to the vanishing point. So we have a guy standing here. Here's his line of perspective, right? Mm-hmm. And I throw a mountain in front of him and the sun up here. Now, you could say this mountain is thousands of feet above his eye level. Agreed? He's standing at the base of a mountain. It's thousands of feet above his eye level. Not everything's to proportion here, right? And so as the sun moves away, it just went beyond the mountain. Okay, beyond the mountain.
But like I said, I was at sea level.
I'm getting there with you.
Oh,
I'm going to show you. I'm going to show you what you're seeing. All right. So it's just beyond the mountain. I just want to let me just pull up something else real quick here. There's that. All right. So
it's the same thing, a larger scale. You know what I mean? That's all that when you're at level, it's going away. It's just obviously traveling farther. I get what you're saying.
Here you're looking up at this building. It's noon, and the sun went beyond it. Now, is that sun below the horizon, or is it just beyond the building? You can't see it. It's just beyond the building. You can't see it. Okay, you're down with that. You follow that?
What?
It's just beyond. It just went beyond the building. So here we're back to my guy. The sun just went beyond this mountain. Now, if I got a balloon and I went up in the air, I'd be able to see the sun again. Or let's say there's a whole bunch of farmland behind me and I could move backwards. So if I move backwards, the mountain's going to get smaller and smaller and smaller. We fill in the foreground. So now I'm 20 miles back and now I can see the sun. Now, the top of this mountain here, is that at his eye level or is it thousands of feet above his eye level? It just appears to be at his horizontal eye zone. Well, you know that it's thousands of feet above him. Now, as the sun goes beyond it, just like it went beyond the building, it didn't go below it. Now, if we add clouds, the sun's up here, the sun is above the clouds, the sun just goes away and it goes beyond it. Now, we got two things going on here. This line right here, which he thinks is at his eye level, is the top of the mountain, which is thousands of feet above his eye level. Also, these clouds, the atmospheric deck, even if there wasn't clouds, the atmosphere becomes opaque over distance. I'll show you that in a minute if you want. And it also merges into this same line. So this line right here is the top of the mountains, thousands of feet above his head. This line right here, same line from your point of view, is thousands of feet above the mountain. And the sun is above that. It just went beyond it, just like it went beyond the building. So you think that you saw the sun set below a horizon. It's just going away. It's just going away.
The horizon is optical, not physical.
Well,
yeah.
In your example, I kind of noticed at that top grid line, the sun didn't really follow that path. That same path at the end there. If that line were to keep going, I don't know. Like if the line were to keep going, the sun would just get smaller and smaller. It wouldn't.
No, not necessarily. There's all different atmospheric conditions that cause all sorts of different types of the way we see the sun. When there's dry air, you'll see the sun get smaller and smaller. Like this. This was filmed in Afghanistan. It was super dry, and the sun went down, 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 and it kind of just stopped there, and it sat here, and then it just kind of went away. Now there's no moisture in the air magnifying this. There's the air is very clear, so we're watching the sun go farther and farther away, and it's just getting smaller and smaller, and it's taking its light with it. And if you wonder, I have Paul McCartney up there. He's singing "The Fool on the Hill," sees the sun going down, but the eyes in his head sees the world spinning round. So this is just a shot from a hill in Bulgaria. That sun is just moving away, or you have to believe that you're on a ball falling over backwards faster than the speed of sound, and the sun is still and you're moving. Every sense tells you you're not moving, and everything tells you that the sun is just moving away, and it's taking its light with it. It can't go. The other thing is I'm trying to find So this is
I think I understand what you're trying to say now. Yeah, I
I
see
like the example of even like street lamps. Like if you're standing on a road next to you, the street lamp above you is high above your head. As it goes down the road, it will look like they're touching the ground, but they're not. You know what I mean? It's just, again, the convergence line of your perspective is bringing everything to a center point. We all know that there's still 20-foot light poles down the road.
Yeah. and you can't see the light post that's a mile down the road. It's gone. It's beyond your horizontal eye zone. So here is the sun. Hold on. Where am I going there? Why isn't that playing? Sun, zoom in. Boom. Boom. Transition. All right. So this is when we zoom out, it looks like the sun is setting already, but there's plenty of space in between the water. So it looks like the sun is half gone, but when you zoom in, you can open up that space that's below it.
You're increasing the angular, the resolution limits of your eyesight. You know what I mean?
Yes.
That's all you're doing. You're just basically giving yourself supervision. And if you could see farther, it would take farther before the sun looked like it was setting.
Right. And then also when you're looking through magnification, here we have a magnifying lens on a table. This boat's just sailing away on a table. It's on the table. It's not going below, but you're seeing it disappear from the bottom up. This is all that's going on here, but you're looking through. We have a Farrell lens there, and that acts like the atmosphere. And that's not a theory. The atmosphere does magnify things over distance.
Atmospheric lensing.
Yeah.
But are those at different levels?
No, they're all on the same level. That's all on the same level. It's on a completely flat counter. How's that boat going below the counter?
Yeah.
Pretty cool, right?
Yeah. But this also brings me to my next question. Why can't we see far? What's stopping us from seeing beyond?
So if you ever been in an Olympic swimming pool, perfectly clear water, you can't see the far wall because over distance, the atmosphere becomes opaque. Jump in there, Mike, and I'm gonna pull up Canada Mountain.
It's basically exactly what we just said. You can't see forever. I mean, we're not superhero. You know what I mean? Like you can only see a set distance. So again, you can only see so far. And then like David's saying, if you add in atmosphere, there's moisture in the air. Like he says, it acts just like a pool. I can see my hand in front of my face, but the farther it gets, there's nothing blocking me from seeing that, right, except for the thickness of the water. Well, the air has water in it, just obviously much less. That's why we can see much farther distances. But the same phenomena still happens with our eyesight, where you can only see a certain amount of distance.
Yeah.
Regardless.
Let me expand upon that. The sun migrates 6 months all the way into the Tropic of Cancer, which is in the north, and then it migrates 6 months out to the Tropic of Capricorn, which is in the south, and the equator is in the middle. And it just circles around the flat Earth. It's small, it's local, it's close. So here's a spot in Aluja, France, where we're looking out on the ocean, and 175 miles out this way is Mount Canigou. But using globe math, the physical math of the globe that is required to be there if we live on a globe, the top of Mount Canigou should be well over a half a mile below the curve. Well, guess what? We can't see it. So maybe it's below the curve. However, twice a year, the sun will line up with the viewer and Mount Canigou. It lines up right in the middle. And when it does, now you don't see me, you see the light that's bouncing off of me. We don't see Mount Canigou, we see the light that's bouncing off of Mount Canigou, but that light isn't strong enough to push 175 miles through the thickness of the atmosphere. However, the sun is much brighter. And twice a year when it lines up, the sun moves away and all of a sudden it backlights Mount Canigou and we could see it. Here is Mount Canigou in its entirety. The very top right there should be over a half a mile below the curve. Over half a mile below the curve. Here's another thing. You are required on a globe to have a set distance where there's a physical horizon, but we only have optical horizons. So here's another mountain. We're looking, and out here there's 7 mountaintops, seven mountains. We can see almost all of the mountain. The problem is the tops of those mountains should be 40 miles below a physical horizon. 40 miles, but we can see them all. So are they refracting up and stopping at eye level to fool us? I mean, if they're refracting up, why don't they refract up and be over our heads? You know what mainstream science says about this? You know what your geography, your science teachers say about this? Nothing. no one will even touch this because it's impossible on a ball.
And again, we're talking like 40, 50 miles. It's not like it's, a couple inches or a few feet, and we're not sure. It's, it's
Right.
absurd the amount of curvature.
40 or 40 miles. This is 20 miles up. So it's twice this height, that much curvature, right? This is the ball, and my mouth is behind the physical curvature. You can't see it. It's gone. There's no way to see it. It's not refracting up and pretending to be level. All observable reality, all math that measures observable reality shows us a flat, horizontal, topographical, non-rotating plane.
Now, you talked about astronomy. Have you ever heard of the inverse square law of light?
I have not learned that yet. I have not.
Well, that's just something where every time you double the distance of something, okay, it gets a quarter of the brightness. The light would be a quarter of the brightness. So with some of the extreme distances with light years, billions of light years, the inverse square law of light literally debunks that. When you take in any of these distances and you start actually adding them together, you wouldn't be able to see any of these stars. And half the planets, anything that they're saying at the distances they give us, not to mention how they even calculated or got these distances, right, is laughable at best.
Take a flashlight, hold it like a foot from a wall, and notice the brightness on the wall. Then take it 2 feet away, 4 feet, 8 feet, 16 feet, and watch. It'll get dimmer and dimmer exponentially. When you get 100 yards away, you're not even going to see the light on the wall because light spreads out in all directions, just like sound. Sound spreads out in all directions. So it can't keep intensifying itself and staying the same brightness. It stretches out. Like if I blew that balloon up and the rubber was the light, the bigger that balloon gets, the dimmer the light's going to get. If I blew that balloon up to a mile wide, would you even be able to detect that there's any rubber? It would be gone. It'd be nothing. And the same thing is
sorry.
Good.
Never mind. Just
no, and the same thing with size. When you double the distance of something, it's a quarter of the size. You with me?
And yeah, so you were talking about how light spreads out in all directions, right? So that's kind of another question that I have with the sun, because exactly half of the Earth is illuminated at one time, and I saw your graphic at the beginning. It showed that the light was reaching different distances. I just want to know how that works. How does it reach one distance, but then in another place it reaches a completely different distance?
Yeah, so day and night are very, very interesting. And if the Earth was a ball, it would be required that exactly 50% of that ball is lit up at the same time. Only no more than 50, no less than 50, always. But that's not the case. On July 8th, 70% of the world is in daylight. Every year on July 8th, because it has to do with how the light works inside of a domed world. So this is date and time converted to a flat Earth map, showing you how this is July. Is that July? Yeah, July, and this is December, and this is how the light works on the Earth. So this is the equinox, September and March, and where it's half the Earth. And I just have a dome light here, and I'm moving this light back and forth, and it's kind of mimicking the same light patterns that we see in reality.
So
weird.
So you're saying the sun is moving?
I believe that the sun is moving above us. It circles around the Earth. I mean, it's
yeah, but I'm talking about for seasons. Like it changes. I guess.
Well, it migrates from Yeah, it
Yeah,
migrates
yeah.
from the Tropic of Cancer to the Tropic of Capricorn, and that's
Mhm.
where you get your see.
Yeah.
That's why in the north
So
you have the 24-hour sun in Alaska. In the Arctic, that's why you have that, because it's making a smaller circle, so it never gets far enough for the light to fully.
Let me show you
for
what's
the
going
sun
on
to
here.
set.
So, well, I just have a question about that. So since they're different radii, is the sun going around in less time whenever it's more in the north, and it's
I
and
know what
it's
you're saying. What
taking
you're
a
saying,
longer time to
no, it takes the same amount of time. Therefore, it's
Mhm.
going faster because this outer circle is bigger than the Tropic of Cancer, so it has to be going faster. It's
So
anchored
the sun speeds up and
on,
slows down.
I'm going to
That's
prove
what
it.
you're saying?
I'm going to prove it to you.
Yeah.
Okay.
Okay.
So, where do you live? What state are you in?
I'd rather not say.
Are you in the north? Are you in the?
Sure. Yeah.
So in North America, in the summer, in June, when the sun sets, it's light still for another 90 minutes to 2 hours. In June and July, it's still light so the sun takes a lot longer for it to get darker, to go from sunset to darkness, 2 hours. In the winter, it's 15 minutes. Sun sets, 15 minutes later, it's pitch black outside. Maybe 20 minutes here, right? But it's different.
We got 1 hour daylight savings time, but we got 3 hours.
Forget that. I'm not talking about the time. I'm not talking about the amount of day. I'm talking about from sunset to pitch black, right?
Yep.
That time. So if the sun is out here, so let's move it out to December. So there it is in December. It's out here. It's going faster. If it was on the equator, it would be going about 1,000 miles an hour. So out here, maybe it's going 1,200 miles an hour. And in here, it's going 800 miles an hour because it's making a smaller circle on the inside and a bigger circle on the outside. Now, what evidence is there that the sun is speeding up? And the answer is, if we live on a globe, there has to be equal phenomena at the same latitudes in the north and south 6 months apart. So in June, when we have 90 minutes of light after sunset, well, then at an equal latitude south in June, they should have, no, not in June, in December, when they're having their summer solstice, they should have 90 minutes of extra light. Here's the thing that happens, though, and we have people measuring this now. They've been measuring it for better part of a year. They're measuring from sunset to pitch black. And everywhere in the world, it's getting less time now. Every day, it gets darker faster after sunset. Everywhere, even in the South, when the opposite should be happening. And that's because the sun is moving faster. And then after that, when it comes back to Cancer, everywhere in the world, north and south, it takes longer from sunset to darkness. Now, different latitudes, different geographical conditions will determine how long that period of time is, but it's getting less for everybody now. And after December 21st, it'll get longer for everybody. That only matches the reality of a flat Earth. It 100% goes against the globe Earth, and there is no explanation for how that could happen on a globe.
Well, can I just ask, what is causing the sun to speed up and slow down? Because there needs to be a force acting on it in
What
order
is the sun?
to cause. The sun is a star.
Is it? It's a gas. So the sun is a bunch of gas in a vacuum that's burning.
It's not gas. It's
made of helium and hydrogen.
Yeah, but it's plasma. Actually, it's not gas.
So do you know how many tons of gas? So the Big Bang happened. All of the gases turned into balls of fire. Stars, gigantic stars, and our tiny little sun. And they've been there for billions of years. they say, I forget the number, but they say our sun burns like 600 billion tons of fuel per day. Some ridiculous number. It's been doing that for billions of years, and it hasn't gotten smaller. It hasn't changed its gravity. I mean, how can it burn?
What?
How can it?
How could it? What do you mean change its gravity?
Well, the sun has gravity because of its mass. If it's expending all of that fuel, it's got to be shrinking. 600 billion tons a day or an hour. It's some ridiculous number like that. And how do you have gas in a void in no pressure? How come? What is causing this gravity? What is causing all the gases to combine?
Once again, it's not gas. It's the sun is plasma, and
what's it made out of?
Gravity. What's the sun made out of?
Yeah.
Mostly hydrogen and helium.
Which defies gravity here on Earth. Somehow it has enough gravity to hold on to Pluto and Neptune and everything except our moon.
Wait, what?
I'm saying,
sorry,
it's made of hydrogen and helium, which defy gravity on Earth, but somehow you have enough of it, it becomes gravity. These are all made up stories that have absolutely no scientific proof behind them. They're just made up stories.
Sorry, you said something about Pluto and our moons.
Well, I said, why does the sun ignore our moon? Why does the sun's gravity able to hold on to Pluto but ignores our moon?
Well, do you know the equation for gravity?
Math is not reality.
Well,
if the sun can hold on to Pluto, how come it doesn't hold on to our moon?
Well, because of the equation. So, this is just how I was taught it. So, if you have two masses and let's say the Earth, like you could take two masses, the Earth and the sun. You multiply those and divide by r squared, and multiply by the gravitational constant, right? And you can take that same equation and apply it to the Earth and the moon. And the Earth and the moon's gravitational attraction is much greater than the moon and the sun's force, like gravitational attraction. So that is my reason. And r squared it's in the denominator. So as the distance is greater, the force of gravity exponentially weakens. So that's why the moon is much closer to Earth, and so the force of gravity is much stronger there.
The Earth's gravity is stronger and negates the sun's gravity, but the sun can hold on to Pluto. Is that your story?
What do you mean negates gravity?
Well, when you have the moon coming around the Earth towards the sun, why doesn't the sun pull it? And when it goes away from the sun, why doesn't the sun slow it down? You know what the three-body problem is? Have they taught you that in school?
I don't know what that is.
Okay, so they can take a supercomputer and they can say, all right, we got a sun, whatever, got a sun, it's got a star, it's got this much gravity, and we're going to put a planet around it, it's got this much mass and distance, and they can put it into motion, and the computer will figure out what it's going to do forever. It'll know exactly what it's going to do, no problem. Mm-hmm. Then they add a third body in, a moon or another planet. And when you add a third body in, this is three bodies that are the same size just to make it easy. But when you add a third body in, it goes into what I call chaos mode. And no computer can figure out what it's going to do next. That's just three bodies, right?
Yeah,
gravitational model. This is how your gravitational model works. This is your gravitational calculations, everything. Nothing can figure out what three bodies are going to do. Do you think there's more than three bodies in the universe?
That's not. So you showed like their starting positions. That's not really how the sun, Earth, and moon are oriented.
Who cares?
At all.
I just made it easy. I just said, let's just start it easy. If you want to look at the gravitational model, of the Earth actually spinning and spiraling, that just compounds the issue. There's no way that, if we have the Earth and all of the planets going in all of their positions, that's more than 3 bodies. How does it actually never change? How come when it's June, we can look up at the stars, and then when it's December, we can look up and see the same stars when we're on the opposite side of the sun? We're 186 million miles across the sun, and none of the stars have parallax. You know what parallax is? Have they taught you that yet?
Yeah.
Okay.
But we don't see the same stars, actually.
Yeah, we do. You don't see the same stars because the day. No. It's because day and night are at different times. But we can see Orion. We can see many of the same stars. But some of the stars will be in the day sky, so you won't see them. But there's zero parallax. Even though we're traveling 4.4 billion miles a year, go out tonight, take a picture of the stars, put a note in your calendar to take that same picture next year, same day, same spot, and every star will be in the exact same position. Zero parallax. Never in history have 2 stars ever crossed each other.
Well, parallax, it's very slow.
How slow is it? How slow is it?
It's 6,000 years ago, the North Star was Thuban.
Yeah.
So, and it took 6,000 years for it to become Polaris. So
yeah. So we just happen to live in the time where we're pointing towards Polaris. Is that what you're saying?
Yep.
Yeah. So let's just debunk that really quickly. The pyramid had the Great Pyramid of Giza has a shaft that points towards Polaris. How did they know it's gonna? You're saying it pointed towards Thuban when it was built, right?
Yeah.
Okay. So that's your story. Do you know about the reason? Well, so do you know about the Georgia Guidestones?
I don't.
So the Georgia Guidestones in Georgia, USA, are a structure that was built. Forget all the messaging on it, which is basically just the New World Order. But there's a hole in this one right here, a thin little hole. And when you look through that hole, we can see Polaris. It never moves. Now, we're traveling 4.4 billion miles a year, never to return to where we were before. We're traveling 186 million miles from one side of the sun to the other throughout the year. Why doesn't Polaris move from that hole? And your answer is it's so far away that the billions of miles that we're traveling create no parallax. That is your story, correct? Okay. Well, the other
problem. What do you mean create no parallax?
Well, there's no parallax. When you're driving down the road or riding your bike down the road, all of the telephone poles are going by you quick, but the trees in the distance are moving much slower. And so everything changes positions.
Well,
that's parallax.
Have you ever looked at the moon whenever you're driving? Doesn't really change positions.
No, it kind of follows you.
Yeah.
Yeah, because that's a whole
it's really far. Because it's really far.
Or, well, that's a whole nother thing. But so here's the thing. Do you know about the precessional tilt of the Earth, where the Earth is wobbling? It moves 1 degree every 76 years. You know about the precession of the equinoxes? The reason that we went from Thuban to Polaris is because of the wobble of the Earth.
Yeah.
Okay, so hang with me. 1 degree in the sky is 3 moon widths. It's about 3 moon widths is 1 degree.
Mm-hmm.
Right? So this was built in 1981. It's been up for over 40 years, and Polaris is still in that hole. It's still right in the center of that hole. It would be a moon width and a half out of that hole. It's not. So then we started talking about it. Mikey started making TikToks about it. We're going all over. It's good. People are like, wait a minute, this isn't making sense. And then you know what happened? All of a sudden, this national monument was hit. A terrorist blew it up, and only blew up 1 stone. And within hours, without any investigation, they bulldozed the whole thing. Now you can still claim that Thuban, was built when the pyramids have always pointed towards Polaris. There is no wobble.
Well,
This proves
so
that we're not wobbling.
It's
proved
pointing at the North Pole. It's not really. It's not like
pointing towards Polaris. It was built.
Yeah.
We know that it was built in 1981. It has information. Look through this hole and see Polaris. It was up for over 40 years, and Polaris never moved. Did the Earth stop wobbling?
Nope, but it's very
but it's
slow.
still there.
He's saying that the wobble would match what has always happened, is what he's saying. So you can't, you know you get what I'm saying? Yeah. He's saying that it was, if we're taking the exact progression or parallel, whatever procession that has always been, that it would now be where, like he said, another moon and a half length, and it's not, which is once you start bringing that again, right, is proof, physical proof through an experiment, through, and something that was put.
And they hastily got rid of it. Getting rid of the evidence, because this was rock solid, no pun intended, evidence. So you were just told a story about Thuban. We just happen to live in a time where Polaris is our North Star, and we're just not seeing it move because it takes so long. That's a story with zero evidence. I just showed you physical evidence that we're not wobbling, but you want to reject it and go with your story because it's in your textbooks. We're trying to save you from a lifetime of wasted effort.
Dave, what'd you go to school for, Dave? What were you in school for?
Me?
Yeah.
I went to school just for business, and I took 4 years of astronomy. You know why? Because we had this amazing observatory on the Copernicus Science Building. And if you were taking astronomy, you had access to it. And so it was fantastic. But everything we saw in the sky didn't match what we were being told. Although you can just believe, right? I mean, have you taken a look at what stars look like through a real telescope, through real lenses?
Yes, I actually have.
And what do you see?
It wasn't a great telescope, so it was just kind of a
here's the star Sirius. Here's the star Sirius, right? And if you do the math on the distances of these stars, you cannot see them. The inverse square law proves the angular size doesn't work. Here, how about this? Since we're talking about Polaris, let's talk about this for a second. The sun is they say the sun's 400 times bigger and 400 times farther than the moon. Therefore, they look like they're the same size. So scaling and distance are a thing according to science. And yes, that is actually true. You can have something bigger and farther, and it looks like the same size. Great. So if the sun was a mile over your head, you went outside, it's noon, and we moved the sun just to the actual big, gigantic sun in the heliocentric world was a mile over your head. You looked up, it would fill the entire sky. Basically, you're on a BB, and the sun's a yoga ball, and it's literally a fraction of a millimeter over your head. You look up, the entire sky would be the sun. Would you agree with that?
Mm-hmm.
Okay, so then we move the sun 93 million miles away, and it reduces from the entire sky to the size of a coin held at arm's length. You with me?
Yeah.
So it goes from, you're looking up, you see an entire sky, and then you move it 93 million miles away, it's now that size. What if we doubled the distance again?
It'd probably get smaller.
How much smaller? It would be a quarter of the size. So it went from the size of a coin maybe to the size of a pencil eraser. Double it again. So it's 4 times as far. It's literally almost the size of a star. Double it again. It's 8 times as far. It's now the size of a star. 8 times as far. 8 times as far is a light hour, because they say the sun is 8 light minutes away. 8 times 8, 64. We'll round down. A light hour away, the sun would be the size of a star. What if we made it 2 light hours away? Could you see it? 4 light hours away. Could you see it? What if we made it a light day away? It's scientifically provable that the angular size, you could not see it. And then the brightness issue, that's a whole nother issue. It would just be so dim. So at a light day away, you could not see the sun. So now how can we use size and variance? Well, they tell us Polaris is 46 times bigger than the sun. So let's make it 46 times farther than the sun. That would be 46 light days away. You could not see it because it would be the same size as the sun, provably smaller than the angular resolution limits of your eyes. And it's, when I say a light day, I've gone far and beyond where it's even a question whether you can see it or not. So at 46 light days away, you couldn't see Polaris, but let's just be generous. Let's make it a light year away. Okay. I multiplied it to almost, times 8, whatever. You couldn't see it. The brightness, you couldn't see it. The angular size, you couldn't see it. Do you know how far they tell us Polaris is? But you don't even know that number, Mr. Astronomy. Not trying to be mean. I'm trying to shock you into not taking the career choice that you're taking.
I'm not sure the
433 light years away. So do you know how close the closest star is to our solar system? The closest star? Do you know how far it is?
It's 4 light years away.
4.5. Very good. You got that. So that's about 25 trillion miles.
Mm-hmm.
If you and I got into a spaceship and we could travel at a mile per second, how many miles would we have gone in 1 year? No.
Sorry, what?
No, sorry.
What was the question?
Sorry. If we were traveling at a mile per second and we went 1 trillion seconds, am I saying that right? A mile per second, 1 trillion seconds. How many miles have we gone? We've gone 1 trillion.
1 trillion miles. Yeah.
Okay. Do you know how long 1 trillion seconds is?
Probably years.
You want to take a guess? I'll give you 3 Bitcoins if you can guess it within a month.
3 Bitcoins? Okay, hold on.
No calculating. 2 seconds.
Whoa. 3 Bitcoins. Hold on.
4 seconds, 3 seconds. Yes, 2 seconds, 1 second.
3,600.
3,600 what?
Years.
Yeah, 31,000 years. Okay. So now think about this. 31,000 years. That's how 1 trillion miles is. So after 31,000 years of you hearing all my dad jokes, we gotta do that 24 more times just to get to the closest star, and the other ones are magnitudes farther. This is ridiculous. This is nonsense. This is absolute pseudoscience, and it's dilute your mind. It's to take you off of the real world, the real creation, and put you in a fake system so they can control you. Because if you believe you live on a globe, they can make you do anything you want, including steal half of your money when you make it.
So yeah, that kind of I kind of have a question on that. So why? So like the field I want to go into, there's thousands of astronomers, and there have been thousands of astronomers for thousands of years. And so why would they just be lying about this?
Mike, you want to go?
Well, first off, man, you gotta realize, man, not everybody, not everyone agrees with the heliocentric model. There are tons of astronomers that don't. They're not getting airtime. It's you have to understand that not every, it's.
Do you have any astronomers that you could name that don't believe in the heliocentric model?
Yeah,
what about Copernicus? I mean, he got all his stuff from Claudius Ptolemy in like 170 AD or something.
Okay.
I mean, he literally, he explained all star trails, southern and south counter and the clockwise, counterclockwise, demonstrated, explained. I mean, he when it came to every pattern that the planetary movements, their yearly travel. I mean, he did all this without telescopes, and I mean that's where Copernicus even got the majority of his work. That's where he got a lot of his thoughts and his ideology to create his theories and all that.
So you said the trails of like the star, like the paths, the stars.
Well, like in the north, they spin clockwise, and everybody will say, well, in the south they're counterclockwise, and that proves we're on a ball. It doesn't. It's just perspective.
Let me show you something. So I'm spinning this ball. Is this clockwise or counterclockwise?
Counterclockwise.
It's counterclockwise. Now watch. I'm going to keep spinning it in the same direction, and I'm going to bring the North Pole over to you. Okay? I'm spinning it in the same direction. I haven't changed directions. Is that clockwise or counterclockwise?
Clockwise, yeah.
Yeah, it changed directions. Look, I'm not changing directions. I'm just spinning it over, and you're seeing this. You're seeing it spin in a different direction.
The perspective of the viewer.
It's the perspective of the viewer.
So yeah, so that's kind of in line with the globe model, because depending on where you are on the Earth, that's the sky will spin. If you're looking at Polaris, it'll spin counterclockwise. If you're looking at the Southern Cross, it'll spin clockwise. Like
no,
it
all depends. If the stars are spinning above us, when I'm looking that way, they're going from my right shoulder to my left shoulder, and when I turn around, they're going from my left shoulder to my right shoulder. So the clockwise counterclockwise thing doesn't matter.
They're always going east to west, and regardless
all the luminaries, sun, moon, and stars rise in the east, set in the west. Always, no matter where you are.
We're talking about clockwise and counterclockwise. So what about the people in the south that say that they're seeing the stars go counterclockwise around?
They've just turned around. They've just turned around. That's it. They've just turned around.
But if it's a flat Earth, and they're looking out on like to the what I call the South Pole. So if someone is looking south and they see the sky spinning clockwise, how does that work? Like, because it's spinning clockwise, it's not going.
So the optics of the sky are no way to prove the shape of the Earth. But when you're watching things move and you're looking at the lights in the sky, which we can prove that their stars aren't these giant balls of gas, they will appear to go in a different direction. It's all perspective, and it has to do with, if there's a glass dome up there of sorts, or we're looking through an azimuthal grid of vision, it shows you exactly how you would see these. I'm trying to show. I have a star rotation. Hold on. Go ahead, Mikey. Why I'm looking this up?
None, man. It just comes down to, like he's saying, perspective. There's a great video, man. I'm not sure who it is that has it, but it demonstrates it so well. I think you're trying to pull something similar up like that.
Yeah.
But again, like if you're, if someone's in the north and you're looking out, again, if it's going east to west, it's still left to right. And now you turn, it's going right to left, but it's still east to west. It's your orientation. It has nothing to do with.
Here's a little experiment I did. I'm just moving this pitcher of water, and the things in the background are spinning in the opposite direction. Because when we're looking up through the sky, we don't even know what we're looking up through. I think it's water. Some people think there's a glass dome or whatever, but the lights in the sky, the motion of the lights in the sky disprove the globe, but it's no way to prove what we're on, because one, they're not these giant balls that are far, far away. How come all the stars are the same size? I thought some of them were 9 million times bigger than the other ones. What?
They aren't the same size.
Well, they look like the same size,
but they're not.
Yeah, but who says? Prove it.
That
observable reality says they're the same size. I mean, there's a couple that are brighter than others, right? But no one has ever seen a star anything other than a pixel of light on an image. No one has ever seen a ball star in space. Nobody.
Well, yeah. You know what? I mean, if they're lying to me, then I guess yeah.
Not some of them are. I think your teachers are not lying to you. I think they're lost in the sauce.
I do kind of have a little question about the motion in the sky. You know about like planets and stuff. They go they're a lot faster than the stars. They go way faster than the stars in the sky, and they're on this one plane called the ecliptic, which is the plane that the planets are on, and we can observe it in the sky. I've actually watched Mars go by in a couple of days. So why do those objects on a single plane go at different speeds than everything else in the sky?
So the actual motions of the wandering stars, which they now call planets, are quite amazing. If they represent like a spirograph, so they're doing these crazy motions, which again, we don't even know what they are. We don't think that there are physical planets up there. These lights in the sky that are supposedly reflecting sunlight back at us, but they look as bright as the sun, are not. They're not, balls in the sky. They're not physical balls in the sky. Let me show you.
They're not rock. It's not. They're not rocks reflecting light. Like
Right.
they're luminous bodies of. Have you ever heard of sonoluminescence? Or
Sorry?
You ever heard of sonoluminescence or the
sonoluminescence?
Yeah. There's like an experiment.
Not heard of that.
There's just real quick. There's an experiment. The scientists take water. It's in a jar. They take water. They add sound frequency to it. Right. It creates like an air bubble. As the air bubble, they increase the frequency. The air bubble kind of shrinks on itself and then implodes. As it implodes, it turns into a light, a star. The nickname of the experiment is a star in a jar.
Right, and it looks exactly like a sun.
Everything is vibration, frequency, water.
Here's the Earth, here's the Moon, here's Venus, and here's the Sun. Not to scale. Relax, everybody. Okay, relax. So
calm down.
So calm down. So let's turn out the lights. I'm right here. It's 4:00 in the morning, so I'm still in the dark. The sun is still below my horizon, and I'm looking at the moon, and there's just a sliver moon. This was the other day, and that's what I saw, a sliver moon. And here's Venus. I should see a sliver Venus. So let's look at what I actually saw. So I'm looking up and I'm looking up at the moon. So I'm looking east and here's the sliver moon, pretty small. And the sun is over there. So now the sun's below or beyond my physical, my horizon. And I'm zooming in on Venus, which is farther than the moon, closer than the sun. And I should see a phased Venus. But look what I'm seeing. How is that? What is that? And I'm not claiming to know. I'm claiming to know what it's not.
It's very far. And this is just what I think. It's very far. And it's the Venus, the orientation of Venus compared to the Earth is like, it doesn't have to be the same as. But the
Venus was on this side of the sun. How am I seeing the whole thing like that?
Is it on? I mean,
I showed you the orientation. I looked it up on a Stellarium on exactly what it was. Right? They tell us this is Mercury, but this is Mercury. This is what we see. This is a light. I don't know what it is. Why are all of the alleged planets named after gods? And this is Mars, right? This is Mars zoomed in with 125 times zoom. Does that look like a dusty, dirty ball reflecting sunlight? This one's a little out of focus, but we're seeing these cymatic patterns in it.
Is that?
That's Mars.
I've looked at Mars in a telescope. It didn't. Look,
what? I mean, how big was the telescope? How much? Go look at it. There's better pictures than that. This is Sirius. This is another shot of Venus. This one's a little out of focus, but again, we're seeing these cymatic vibrations in there. Insanity. This is the Voyager spacecraft over a couple days. So we're seeing all of this rotation, all of this movement of the clouds. But when we see a picture of Saturn from 25 years ago and one recently, every single cloud is in the exact same place. Every single. No, Jupiter. I'm sorry, Jupiter. So this is Saturn. This is the famous picture of Saturn. We took it, put it in Photoshop, cranked up the levels, and we can see that it was just slapped together sloppily with different layers.
I did this myself as well on my iPhone.
Yeah. So this picture is 100% not theory, proven fake.
And that's
from
on the
NASA.
official website. Yeah,
Yeah.
that's on the official site.
Yeah, from NASA,
Mm-hmm.
right?
Mm-hmm.
And then they do stuff like this. This is the latest picture of Pluto, right? They caught a bright picture of Pluto traveling at 60,000 miles an hour as the Voyager or whatever it was that went by. Snapped this picture, sent it back to Earth. Weird that it looks like the dog Pluto. That's just weird.
That is weird.
Yeah. And then they show us this. Then all of a sudden this is Pluto. I mean, the images that they show us are just absolute insanity. They want people just to believe anything.
Mm-hmm. So what? Actually, I kind of already asked that
Good.
before. Oh, like what do they gain from lying about planets? Just saying that these objects in the sky are there. There's not really like, at least in my mind, at least there's no reason why lying about there being planets in the sky would be necessary when there's not really a reason for that.
Well, they used to be called wandering stars. They before, in the ancient times, all ancient cultures that have they all depict, it's all level plane. It's all flat Earth astrology, for a lack of a better word. It's all topographical planes. I find it interesting how, we consider them to be primitive or, ancient. They were stupid, so to speak, yet, they seem to have a better grasp on, the cosmology, some of the buildings and how they were able to line up certain structures perfectly in line, using advanced mathematics. These are people who are using chisel and hammer and rocks and beating stuff, yet they have perfect math, perfect geometry. They're lining up literally perfectly with certain constellations, stars, wandering stars, planets, whatever you call them. The model is the lie. It's not even the stars. We've always known that there's wandering stars. Again, if you when it comes to astrology, some people think that these have, these affect us and whatever, who knows? Maybe they do. Maybe there is other reasons besides just the model about why they lie about it. But as David said, it is interesting that when it comes back to, the whole, if we're on a level plane and we have a dome, right, that obviously that's an intelligently designed, that's creation. So right. If you're despite creation, right, what better than to put, the other false gods as the names of the planets that is in the model that's deceiving you about who you are, that you're created by the creator. It's just interesting. You'll find out that there are just so many odd connected coincidences that just seem to arrive at every turn.
If you look, divine law is the law of God, common law is the law of the land, and then statute or maritime law is the law of the fake globe, the law that man's law. So in order to convince a man to give up his divine rights, his God-given divine rights, his common rights, you have to convince them that they're not in a divinely created into a divine world, that they're not divinely created into a divine world. So a lot of people are like, well, I don't believe in God or in anything like that. Well, this isn't a religion or anything. This is absolute proof that we are in a created world, that we are at the center of creation. This place was created for us. We have divine rights. We have all of this stuff, and they're not allowed to take it away from us unless they tell us we agree. Well, if you believe you live on a globe, if you, register everything, if your birth certificate gets given to a corporation is a dead entity, and it is basically using you as fuel for their fake system. They can't take us out of the natural, God-given natural system of nature, but they can try to pervert it. And if we agree, we're playing on their ball field. So this is about slavery. This is about controlling mankind. This is about pure evil. And a lot of people aren't willing to look at that. And, I'm finding that, high school kids, all they're worried about is going to college and partying and, getting into more debt and then working a job for the rest of their life to pay off their debt. Now, that's all part of the system to keep you as a debt slave. Money is fake. Money's fake, but we need money to operate in this world. So, that's the system. This is all about slavery. And unfortunately, I used to friggin' love astronomy. I loved it. I was really good at it. And it's all pseudoscience. all of it.
Well,
That
now,
seems to
thinking
be-
just out loud, something I talked about the other day was, if you found out, right, we verified the Earth's flat, right, we're created, and it's what it is, right? What would be one of the first things you would do, right? You'd want to explore. You'd be testing out. You'd be trying to find your bound. That's what the elite families, the government, whatever you want to call them, that's what they're doing. Like, they're using our money with all the operations, sending jets, they're hitting the dome, whether they're trying to penetrate, whether they're trying to find weak spots, whether they're trying to take samples of, and find out what it's made. They're doing what anybody else would do. They're just doing it they're just evil people. So, they're just doing it the wrong way. But that's what they're doing. They're constantly out, going to Antarctica, going to these other places deep down in the ocean, going up, trying to launch things. They're constantly doing things that anybody else would be doing if you had free reign to explore your world. You know what I mean? They're just keeping us busy and using our tax dollars, our money, and our energy to accomplish what we should all be doing, for ourselves independently.
Well, yeah, I do kind of have something on this. So yeah, them sending like these rockets or whatever missiles into the air, it's from how I see it's for a reason. It's to put satellites in the air, and things like satellites and telescopes in space. They're very important to how the modern world works, especially right this second, because from what I know, the whole reason why this we're able to even use the internet to have this live chat is because a satellite is putting this on our screens. So
That's actually false. That's actually false. 99.9% of all communications are done through undersea cables connecting the continents. And if you look at the configuration of the cables, they don't work on a globe. They only work on a flat Earth. So that is where all of that's coming from. So you believe that we have satellites in space that are following all of the spinning in the orbit. We have a geostationary satellite. So if you remember the image I had of the Earth spinning, right? So we're spinning and orbiting, we're corkscrewing through space, and somehow that satellite is following us, maintaining its exact spot geosynchronous while we're spinning, while we're orbiting, while we're curving around the sun. And somehow those satellites just stay there.
Mm-hmm.
That's not unbelievable. I mean, do you know who controls all the helium in the world?
Who controls the helium?
Yeah, who controls all of the helium in the world?
The largest consumer of helium.
Largest owner of helium companies and consumer. That would be NASA. And NASA admits they have tens of thousands of satellites hanging from balloons. Satellites hanging from balloons.
I've never actually heard that before.
Okay, but when you look into it, you're going to find out that it's true, but you don't hear about it. This is your money that you pay into the tax dollars, into NASA's $80 million a day, and they're putting satellites up on balloons that can stay up there for years at a time.
These balloons are bigger than football stadiums. They are like altitude balloons. They're massive.
But even then, I've seen satellites go across the sky.
Have you seen a satellite go across the sky, or did you see a point of light move across the sky? And when you do
it was flashing slightly red.
So. Well, it doesn't matter, because the seeing a satellite is you have to again do the inverse square law of size, and then you'll realize that you can't see a satellite like that. I'm trying to show you here.
I want to ask you, what is this inverse square law, and what's the equation that you're using, and what
the inverse square law of light is
equation for what? Yeah,
is every time you double the distance of something, it's a quarter of the size, and the inverse, every time you half the distance of something, is 4 times bigger.
So, but that's being bigger. That's not brightness.
Brightness too.
Really...
It's 4 times brighter or 1/4 of the brightness. Same thing. Test it out. Look it up. So this is what we have to believe. You know, we're spinning and whirling and twirling, but all of these satellites are just somehow maintaining their spot, and somehow they have enough energy and power, electricity to transmit, you know, all of these signals. That is insanity. But to say you saw a satellite, so here is a 747, gigantic plane. If you're standing underneath it, you're literally an ant. Okay. Mm-hmm. Here's a 747 at cruising altitude. Can you see it?
No, but that's during the daytime.
Okay, well, at nighttime. So it doesn't matter. You can barely see the airplane. Can you see the engine? Can you differentiate the engine on this airplane? The engine's bigger than a satellite. Now, a satellite that you saw, the minimum distance is 50 times higher than this. 50. And you think you saw a satellite? You saw the sky.
The thing with the plane, so at nighttime, the plane turns its lights on, and you can see the lights from the plane.
At 5 miles high. Can you see it at 250 miles high? No, you cannot.
You should be able to.
No, you can't.
I saw the lights from the satellite.
You did not see the lights from the satellite. You saw a light in the sky. You don't know if that light was 5 miles up, 2 miles up. You don't know what it was. Was it man-made? Was it natural? You don't know what it was. And there's so many lights in the sky and so many satellites that if you say, oh my God, I saw a satellite, you can go on a satellite tracker, and a satellite, it'll tell you exactly what satellite you just saw. So think about this. I create an app and I say, there's satellites everywhere. In every sector of the sky, it'll tell you what's in that sector at that time. I just saw a light in that sector. I can look at the app and go, oh, that was G75 satellite. That now I believe
the Starlink.
I know all about Starlink.
I actually saw those for myself while I was at camp. They went over the sky.
Yeah, I saw them.
Rigid line.
I saw them too. Saw them too. Now, if you were using your God-given common senses, one, you would know that those are very low. Two, if you listen before they got there, there's 2 jet fighters in front of them. And then if you listen after they go, there's 2 jet fighters behind them, squaring off a grid of space that they will not let any other airplanes in.
I didn't hear any.
You didn't, but everyone that listens, we're all hearing these jets. And so, anyone listening to this, if you see Starlink, be quiet, listen after it passes, and you'll hear those jets. Hang on.
Is that nighttime?
Hang on.
Sorry, I'm sorry.
The Starlink satellites, you know how big they are? How big are they? They're the size of a friggin' desk. Smaller, way smaller than one of these engines. And they're how high are they? Let's say they're only 200 miles up. You think you could see a Volkswagen 200 miles away? Absolutely.
Well, if the sun is reflecting off of it.
So the sun is reflecting off of these non-reflective things. They're actually lights. Next time you see it, look at them. They're lights. They're not reflecting sunlight. If it was reflecting sunlight, it would be reflecting it over there, but not over there. But everybody everywhere that's underneath it can see it. So they're just seeing lights in the sky. It's a trick. It's literally a trick to convince you the Earth is a globe, to keep you a slave. So they drag some lights in the sky with some craft that we don't even know what it is. It could be electrogravitic, stealthy craft, pulling some lights behind it, and you think the Earth is a globe because you saw some lights in the sky.
Well, that's not
you couldn't see. Well, why do you think the Earth is a globe?
That's just it's what I can observe. It's what
you observe something that you couldn't observe if it was what you were actually think you're observing. You could not see something the size of a school desk 200 miles away. You couldn't. I don't care if it was its own light. You couldn't see it.
Dude, not to mention even satellites. Like you have to understand, most satellites are in the thermosphere, where the elements used to create satellites melt before the Curie point, or the melting point for them, is far less than the average temperature they're even residing in. I'm not sure the exact numbers right now. I know a few of them, not aluminum. There's different. There's Kevlar. There's something out there. There's a whole bunch of different ones, and literally like 4 of them all melt before the average temperature that they reside in, which makes no sense. I mean, that in itself should be enough to make any normal, make someone go like, "What's going on?" It doesn't even make sense. I mean,
right. And we've there's many cases where one of the famous satellites is the Japanese satellite, the Himawari-8. You know about that one? It takes a picture of the Earth every 15 minutes, and basically we found their server, their FTP server, and we got in, and it shows millions of files, folders, and it basically shows how they create each image. They have weather data with all the clouds, because that's the big thing about the Himawari satellite. The clouds are right. Okay. And so we found this FTP server. I'm just going to fast forward through this, and we can go in, and we can see that they have this map, and with the weather that we found the servers that they go to. They put it on a ball, right? Then they add the terminator line. For this image, we saw this raw image, and then they add a terminator line. So if Himawari-8, this is the final image, took this picture, how did they see the clouds that were over here? How did they see the clouds that were over here? Right? These are the images.
Type of camera that detects.
No, that they don't have that type of camera. That's not what it's talking. But we also showed that they had the blue marble blank.
Why is it green? Why is it green in the middle?
Because this is how they were putting it together. We found the raw files. Raw files.
Okay.
And
it's computer generated.
Yeah.
Okay. Yeah.
And so once you catch faking one thing like that, then you have to understand that the rest is fake. This is going to be a rough pill for you to swallow. You can just ignore everything we did and follow your career path. And you're going to one day find out that this is all everything about space is fake. Try to find a photograph or a picture, a video of a satellite in space. Can't do it. Doesn't exist.
Everything you find,
there's videos of people at the International Space Station. Yeah.
Yeah. Now, where are the satellites behind them? Where are the stars? Where are satellites? Can you find any picture of one of the 10,000 satellites?
Where are the satellites behind them?
Yeah. Sorry? Like if they're panoraming into space, where's one of the 10,000 satellites that are orbiting behind them?
Well,
one anywhere.
You asked a video of Earth, but I mean, yeah, I guess I haven't seen specifically a satellite whiz behind them.
Well, just anywhere. They'll show you a stock photo, but that's a computer generated. I'm not talking about the one where it's like a selfie, a perfect picture. I'm talking about where just anything, a star, they'll tell you stars. It's the brightness of it's the exposure that, you can't see the stars. Okay. Where's the satellites? Where's a meteor flying by that? Where's anything besides, bubbles,
Well, yeah, the satellites are, there's a lot of satellites in the sky, but that's your belief. The Earth is also very big.
Yeah,
This is once again, this is just my belief. I don't want to be like.
Got it. So let if I show you them faking, well, go ahead, you first, because I want to go to the ISS.
So the satellites, there are a lot of satellites in the sky, but the Earth is very big. So it's not like there's a bunch in the sky and they're all right next to each other. They are very far apart. They're still very far apart.
I get you. Yeah. But you don't think that during any servicing, launching, that they would actually have a photo or video of it? They don't. This is a cool shot from the ISS, and their cameras always are, in a place where there's crap in front of them. That's just to prove they're on there. But this is a picture from the ISS, from their live feed. Now, if we look at it, we can see these rivers, these water areas, and that is this little square. Okay. So how this is just a fisheye lens from a balloon or from an airplane. Let's look at another one.
Well,
so this is from NASA. And we got Africa here. Well, here's this. So you have to believe that all of this land is on the other side of that ball. All of that land is on the other side of that ball. Here's another one. This is a live shot from the ISS. All of this whole curve of the Earth is all here in this little circle.
That enough right there should be. I mean, look at the Earth from their photo, dude.
Right.
I mean, you think you're seeing the other side of Canada? Like,
here's another one.
I mean, that's crazy,
right? And then this is the famous 2002 or 2012 photo. So we look at this and we look at the world map and we say, okay, well, what can we see on there? We can see it right here. So all of this land is on the other side of that ball. But remember, before we saw this and all of that was supposed to be on this side. But now we have this and all of this has to be on the other side. If your brain is going, I can't figure this out. And you know why you can't figure it out? Because you can't figure it out, because it's fake, because it can't happen. This is 100% proof that these photos are fake. And until you're willing to accept that, you're going to be in a tough situation.
So you said it was a fisheye lens, right?
What's that?
You said it was a fisheye lens. You said it was a fisheye lens.
Well, I'm showing you that they use a fisheye lens to fake the curve. Yes. So
yeah. So it's showing that area, but it's past like the other part of the Earth. I guess the other half. It's not showing half of the Earth because it's on the other side of the horizon. So
where all of that land fits on the other side of the other side of this, because right here, this is
you said it was a fisheye lens, right?
No, this is not a fisheye lens. This is a photo of Earth. Supposedly, it's not a photo of Earth. It's a painting supposed to make you believe in Earth. So this isn't a fisheye lens. All of this land has to be on the other side. This is a photo from 1 million miles away that NASA gave us. And NASA doesn't want to lie. Mm-hmm. They don't even call it a photo. They call it an image.
Got it. Yeah.
So they're using all sorts of fakery on the space station. This is this. Watch the color. The balls turn blue, back and forth. It was a glitch in their system showing you that they're using photo layering and all sorts of stuff. Here is Kamala Harris supposedly talking on the space station. And so the guy's up there and watch what happens. He's playing with this wire. Now watch carefully as that wire goes right through his wrist. Okay, watch his wrist near his watch. And the entire wire is going to literally slice his hand off. So he's going to come in. Now watch the wire. Here it comes right through. Boom, right through. This is showing you that that's not real. They're faking space right through his wrist. It's right inside his hand. Okay. So you can write that off like, oh, well, I don't know. But then they show us this.
There's tons of these.
Yeah. This is from when I believe it was the Soyuz was meeting with the space station, and they're like, oh, look out the window. We can see the space shuttle is docked to the space station. Do you think this is real? Look, it comes inside the window frame. They screwed up. This is horrible.
That's pretty bizarre, yeah.
And this is from NASA, right? So this is you're in space. They get one shirt a week, one washcloth like every 3 or 4 days. They don't get to take showers. She's got a rod. This rod goes out to this door and closes. How does that rod not let air leak out? How do you have a physical rod going through there? Now, is she looking at the door? Is she looking at a monitor? She's turning her hand, and if you actually look, it's not matching exactly. But worse than that, look at this woman. Look at her hair. Look at her face, right? She's having a good hair day. Look at her makeup. Who does her makeup in space? And how does she wash it off? Okay, you don't have, this is caked on makeup. And this hair, that's a good hair day. What do you think, Mikey? Is that a good hair day?
I don't know.
Have you had a good hair day like that?
Come on, man.
Have you had a good hair day?
Oh, dude,
okay.
I got to get some hair first, man.
And then here's all the guys are having a little talk with the news station, and they're like, could you do a flip for us? And then when they do a flip, I'm going to fast forward. First, this guy, he's going, where's he going? and he gets caught up. He gets tangled in his wire. So now he's stuck. And they're kind of freaking out. This guy's going to jump out of the scene in a second. It's like, okay. And they're all kind of laughing. This guy is like, all right, let me go over here. And the guy in the orange, in the red, he wants to get over here because there's a lever. And when he pulls it, you hear this big click and the wires reset. And watch right here when he pulls the lever. So he's going to like look around. This guy's going to look around like, oh, what's over there? And he's going to reach over to the lever. You hear click and watch. You see that? It released the wire. And so I'll show it again. I'm going to zoom in on it. Yeah. So when he does it, watch his shirt here. Click. And there it goes. Click. Right. Interesting. So wait, I'm just warming you up here. I'm warming you up. Right.
Yeah.
So you only need one screw up, right? This guy is showing something and he dropped it. Whoa, why did it fall? Why did it fall? And then he's like, oops, what happened? He dropped it and he had to catch it. He dropped it and he caught it.
Where's that?
Well, and you know what NASA says? They hit a pocket of gravity. Did they teach you about pockets of gravity yet? Okay.
They have not.
They have not, right? These are excuses. So these guys are all like, oh, look at us. Hey, well, how's this fruit just sitting on the table? How's that fruit just sitting there? Well, maybe it's a sticky table. Maybe they didn't, maybe they're sticking it. But here's the best one. They got some fresh fruit up there. They got a lemon and they were playing with the lemon and it went away. The lemon's not real. It's augmented reality. Watch again. I'll zoom in. Why are they faking stuff? Watch again. Okay. So this alone proves that ISS doesn't exist. There are no videos or photographs of the ISS being built. It just appeared.
Well, not to mention they have an exact replica inside a swimming pool in Texas.
Yep.
An exact replica inside a swimming pool in Texas.
The exact replica.
It's called the National Buoyancy Lab.
The
neutral buoyancy lab.
Mm-hmm.
And
then there's, people started finding like when they're looking at some of the footage, they're finding bubbles constantly coming out. And that's where the whole hashtag bubbles in space. And, I mentioned that earlier, and that's where a lot of that comes from, is people seeing air bubbles coming from either their suits or certain things they do, the helmet, whatever it may be, as well as there was a news article where one of the astronauts nearly drowns in space, right? Literally drowned in space. They're talking about putting snorkels in the fuck. I mean, come on, dude. You got to ask yourself at some point,
Yeah. Yeah, I haven't really researched any of that. I can't really say, put what I know on this. I don't know about
it's a lot.
People in the International Space Station. Yeah.
It's a lot, but once you look into it, here's the problem is you Google it, you're not going to find anything. You're not going to find anything. They've hidden it for you. Let's say you were interested in underwater basket weaving and you saw a cool video 2 years ago, 2 months ago, 2 days ago. You can go to YouTube history and search underwater basket weaving and boom, there's the video. You can watch Mikey's videos, my videos, Jaronism's videos, all of the real flat earth videos. And then they'll be right there in your search history. But if you search your history, they all disappear and only propaganda videos show up. Why is that?
Honestly, because I don't really know personally how to verify the
anything.
I just don't know how to verify whether these claims about the International Space Station are true. I would like to get back to looking at things that both of us can see and how that, because that's really what my paper is about. It's not really about the conspiracy. It's about what we can observe, the physical phenomena that we can observe and how it correlates to the flat Earth.
So let's we can't do this. We only got a little bit amount of time, but what do you want to talk about? Do you want to talk about boats over the horizon? What do you want to talk about?
I guess this will be my yeah, I guess this will be my last question. So, okay, like a little bit ago, there was, the solar eclipse, and I saw this solar eclipse with my own eyes. I saw the moon go in front of the sun and
Saw the moon go in
then
front
go
of the
away.
sun.
So what is a solar eclipse, and more importantly, what is a lunar eclipse? You know what a lunar I you definitely know what a lunar eclipse is, right?
Yeah. So
Yeah.
so
Yeah.
so first thing is, when you ask us what is a solar eclipse, we have a lot of ideas, but we're going to show you that they're not what they tell us. So falsification is independent of replacement. So if we prove something false, you can't say, well, to tell me what it is. Like if you were accused of murder and then I said, well, he wasn't in Connecticut, he was in Hawaii at that time, and prove it, then you can't say, well, then who did it, right? That doesn't matter. Falsification is independent of replacement. So let's look at
Shifting the burden of proof is
shifting the burden of proof. So
Well, I'm saying that I saw the
you
moon.
you
I
did not
saw it.
you did not see the moon. You saw the eclipse, right? Mike.
Oh, wait, I get what y'all.
Yeah.
I get what y'all were saying. Yeah. Okay.
I'm trying to find something right here. Why you looked at Mike throwing?
Well, I know that the moon has never been filmed entering or exiting a solar eclipse. It's never, the moon's just not there, but it's causing the eclipse. Yet no one's ever recorded that.
Yeah. So what are we seeing here? Are we seeing the moon? Nope. We're seeing the sun with a missing part. We're seeing the sun with a missing part. Sun with a missing part. Sun with a missing part. So as we look, like that could be the moon, but why don't we see the moon? Right? Because why?
Because the side that's being illuminated is on the other side of the but facing away.
Why do we see a full moon in the sky?
Why do we see a full? Because the moon is on the other side of the earth.
No.
So the side that's being illuminated is facing towards us.
Right. So and when you're out in the middle of nowhere and there's a full moon, does it cast a shadow on the ground? It does. Can you read a book? Sure. Can you drive with your lights off? Absolutely. Because the moon is reflecting light. So when you're watching a full eclipse, let's say this is a full eclipse. Well, if you were on the moon looking at the earth, there's a full earth. So the earth is 6 times bigger and I would say more reflective than a dusty, dirty moon. So that's at least 6 times brighter. So the earth shine should light up the moon. No infrared camera, no shots from the space station, from anywhere. Nobody has ever seen the moon actually eclipse the sun.
Yeah.
All they see is missing sun.
You said that the earth should illuminate the moon.
Yep.
Even though the sun is right there.
Well, when there's a full eclipse, even without the ring of fire, nobody can see the moon, even though the sun is being blocked.
Because the sun is the corona of the sun is still there. It's still very, very bright.
So what about infrared photography?
Infrared?
Yeah, you cannot film the moon with any type of optics, is what I'm saying. It's never been filmed or viewed entering or exiting in the eclipse, period. You would still be able to see it through some sort of photography. Whether you could see it perfectly with your naked eye from a distance, okay, I'll give you that. Thermal, infrared, I mean, whatever, you have a way to see it.
It doesn't matter which, if you use a thermal or infrared camera, because the sun is still right there.
Yeah, but if we're taking away the reflective nature and we're just talking about the heat signature, right? There would be a difference between the sun and the moon would show a different heat signature. You would have 2 different colored circles near each other. You would have
and also you know that there's cameras that have a disc in them that will block out the sun so you can actually see the corona and film the outer limb of the sun. There's cameras that can create a fake eclipse. So during the ring of fire, you can also block out the ring of fire, and then you're not blinded by it. But to believe that you're blinded by the ring of fire is just a belief to make up an excuse. So here's the thing: no one's ever seen the moon approach, eclipse, or exit the face of the sun. And I have a pretty damn good explanation of how it happens, and some observable reality. And I did a little experiment, and it created the exact same thing. Let's switch to the lunar eclipse, which is what causes a lunar eclipse?
The Earth, or no, the sun. No, oh my gosh, the moon goes into the Earth's shadow.
Correct. So that would mean that the Earth gets in between the sun and the moon. Okay. So if I'm standing here on the top of the Earth, is the eclipse happening yet?
What do you mean? Like
if I was right here, this picture right here, this orientation, is the eclipse happen? Doesn't look like it is. But if I move the Earth up more in line, all of a sudden we have a little bit of a shadow. Okay. Yeah. So that is essentially what should happen, right?
Yeah.
Unfortunately, this is called a Selenilian eclipse. And over 50 have been documented where the observer here can see the sun above his horizon over there, the moon above his horizon over there, and the eclipse has already started. And to make it worse, the shadow comes in from the top. Yep. What that proves, the shadow comes in, doesn't come in from the bottom. The shadow comes in from the top.
Where's this been documented?
Exactly. Look it up. Seleninian eclipse. There was one just last year, I believe. And you know what the astronomers call the Selenilian eclipse? They call it the impossible eclipse.
And now that's observable.
But I'm talking about a lunar eclipse specifically.
This is a lunar eclipse.
That is lunar.
This is the lunar eclipse.
Yeah, I'm talking about whenever the moon turns red, like whenever the moon goes red.
Well, that is a whole nother thing. If you look, I think it has to do with polarization. If you have a polarized film and you get one this way and then you get the other one this way, it literally makes it opaque. If you add a third one onto it, all of a sudden you can see through it again. That makes no sense. And this is beyond what we can explain here in this podcast. On my app, what you need to go to the eclipse section and watch all of the eclipse videos there. You'll learn a lot, more than you'll learn in in your astronomy class. But the Seleninian eclipse proves that it's not the Earth causing the eclipse, period. And also, when you take a ball, right? When you take a ball and cast a shadow on another ball, it comes in as a long ellipse, it spreads out, and then it leaves as an ellipse. It doesn't come in as that perfectly curved that we actually see. We don't know what that is. A lot of theories, a lot of ancient cultures that talk about other bodies in the sky. I don't know what the story is, but that's it. And the other problem is you can't demonstrate how something can cast a shadow at any great distance. So take a basketball, put it on the ground at noon, and look down around the shadow. You'll see a perfect shadow of the basketball. Lift it up a foot, you see a pretty bigger shadow. Lift it up 10 feet, the shadow's gone. The shadow literally will spread out. Lift it up 238,000 miles away, you can't cast a crisp shadow on anything at that distance. Light goes around. Light just spreads out and scatters. So you can't cast a shadow at that distance. It's not going to work.
That's a basketball one. But I'm talking about specifically about, you said polarization or something. I'm talking about the moon turns red whenever it's directly behind the Earth, like whenever the Earth is directly in between the sun and the moon, the moon turns red.
Why does it turn red? Why does it turn red?
Well, so I'm not an expert on this. So the light from the sun is being, I guess, what, because the Earth is in front of the moon. It's in between the sun and the moon. So if it's right in between, that means the sun, most of the sunlight is being blocked, right? So due to, I guess, refraction, it's the light gets spread out. Okay, it gets spread thin, and that's why the moon darkens and it turns red, because the light is spread thinner. That's the explanation I got.
That is the story you've been told, and I say, cool story, bro.
And I want you to tell me why I'm wrong and why the flat Earth model is correct. Well, like why the model of a lunar eclipse turning red is.
Well, what I'm saying is we can prove it's not the Earth causing the shadow. That's it. We've disproven the globe model. And now you want to come up with another model? Sure, we can talk about it, but it doesn't matter. You've disproven your model. The Earth is not involved in the eclipse of the moon, period.
Why was that again?
Because you can't have it unless the three of these things are in alignment. And the eclipse started before, when they're both above the horizon, proving they're not in alignment. You can see both of them above your own horizon, and the shadow comes in from the top, if it's even a shadow. The darkening of the moon, the powering down of the moon. I don't know what it is, but it's not the shadow of the Earth.
But then it turns red.
It doesn't matter.
Why?
What is? Yeah. Well, how? The whole explanation of it turning red as it going through the Earth's atmosphere, I don't buy that at all. It doesn't make any sense.
And I also want to get confirmation on the you said just to look up the Selenian eclipse.
Seleninian.
Sorry.
Don't hurt yourself.
Right? Yeah. I hate that word. I like calling it the impossible eclipse, because it is. It's impossible. So check this out. So the sun's 400 times bigger than the moon. It's 400 times farther. They look like they're the same size, or maybe they're just the same size. And the odds of them lining up for a perfect eclipse are so infinitesimally small, but let's just say it's 1 in a billion, right? But it happens. The odds
1 in a billion.
What is it?
We can actually do the math to figure it out. I'm not sure.
So
I don't actually do that math myself.
Yeah, math is not reality. You got to hear me out.
But we can predict an eclipse.
Yeah, how do you predict eclipses?
With math. We can predict where it's gonna be. It's at the same speed. It rotates at the same speed. It revolves around the Earth at the exact.
So the sky is a perfect clock. The gravitational sky that we can't model in any computer somehow is a perfect clock. Well, everything is held down by gravity. The sun and the moon and the planets are all moved around by gravity, but somehow nothing ever changes, and it goes into this perfect pattern. Now, the chances of it happening a second time are infinitesimally small, and again. There's
actually going to be one happening in April too.
Well, I'm aware. I'm actually going to this one. So there's a cycle of eclipses that repeat every 18 years. The same eclipses happen every 18 years. Do you know that NASA gets their eclipse information from one guy who uses the old Soros cycle, which is based on a flat Earth cosmology?
I didn't know that. I've never heard that ever.
Yeah, well, you didn't hear about them using balloons. You don't hear that they launch 2,000 balloons. 2,000 balloons simultaneously, twice a day, every day across the Earth.
Really?
Yeah.
There's a lot we haven't been told, man.
Yeah. Every day they do this at the exact same time. Everyone lets go of their balloons. And that way it picks up all of the weather data, all of the wind streams, and it goes back to a big supercomputer, and they map out the whole world. And that's how they do flight planning and everything else. and that's how they know where to what altitudes to put their balloons at to get them in the positions that they want. It's all done like that every day, but they don't tell you about it. You can find it. There's actually, information on it, but it's not something that they're going to educate you on.
Okay. Yeah. Yeah. And sure. I guess, yeah, they're just not telling me that's
right.
That could be true.
Right. Here is the moon travels in between the tropics every 2 weeks. The sun travels in between tropics every 6 months. Right. So this isn't the scalar speed. And occasionally when they meet at a node, that's when we have an eclipse. And
so you're saying it is the moon?
Well, that they meet at a node. I don't actually think the moon is there. When there's a new moon, I think there is no moon. I think it's just a node. But again, I don't know what it is. I don't know. But on a flat Earth, you can explain a lot of this stuff. I don't know if that's the right way to explain it. What do you think, Mike?
Well, the big thing is, I want to leave you with is that flat Earth is not about proving a flat Earth model. It's about debunking the globe through observable science, scientific method, experiment. It's about proving we're not a globe. Everything we can measure, everything we see and test is level. Now, is it a level square? Is it a level triangle? Nobody knows, dude. It's a level plane. Flat's not flat's not a shape. That's a descriptive word. It's just a cool, it's a cliche name that they put on it, but it's a level topographical plane. You know what I mean? It's burden of proof is on the globe. No curve, no motion has ever been proven, and gravity is an unproven theory. There's no scientific method experiment to prove gravity being the force or of anything that pulls us down, rather than it being density or buoyancy in relation to a medium. So with the three things you would have to have, curve, motion, and gravity, none have been proven. So we have a lot more questions for y'all than y'all do. That seems to be the thing.
The Cavendish experiment in the 18th century actually.
Yeah.
It actually found the gravitational constant, which no.
Go ahead, Mike.
No, dude. Well, I'm not super great with the Cavendish, man. I know Michelson Morley. I would tell you to look into his experiment as well. I know Cavendish. I don't know the specifics enough to go into that.
Well, the Cavendish experiment, a guy had 2 lead balls in a barn and filmed them through a rifle scope or something and said that they attracted each other. But he's ignoring electrostatics. I mean, there's a whole bunch of reasons why those things would have moved. But 2 lead balls, how come a plumb bob next to Mount Everest doesn't tilt to the side? That has a lot more gravity than those balls. And it makes no sense. That the Cavendish experiment has been debunked 1,000 times over. Again, if you want to learn about that, on the app, there's a section on the homeschooling called Schooling Globers, and there's a section there's one of the issues on Cavendish.
I might take a look at that. But I mean, I know that they actually use that experiment in colleges. They
do a lot of stuff in colleges.
They
Hey,
do.
do you got time to touch on a couple of the southern flight routes? I think that one always I thought is pretty self-explanatory, easy, and again debunks curve, motion. I mean,
sure.
If we're trying to
George,
prove Earth,
So let me ask you a question, George. If this is the globe, you got the equator around the middle, so everything above top half is north, bottom half is south. You with me?
Mm-hmm.
Any 2 airports in the north, any combination, anywhere. I don't care if they're, in Florida or in Germany, whatever. Any 2 airports. Would that plane ever need to go below the equator to get to its northern destination?
Probably not.
Okay. You're absolutely right. And no northern flight to any northern airport to any other northern airport ever goes below the equator. Would the same be true for southern flights that are flying upside down under the spinning ball? Would they ever need to go into the north to go from one southern location to another?
Probably not.
Well, they do. That's the problem. So let's take a look.
See, it's these things like you just kind of I kind of want to stick to the questions where like we can both see this, because you like I have no way to I can't just go on
You
to
can go verify all of this. This is stuff that you can verify. So why would this flight route on a globe go all the way up from Buenos Aires to Amsterdam and then all the way back down to Johannesburg, right? Well, this is what it looks like on a flat Earth map. That one's not that great. Let's look at another one, right? So this one here goes from Auckland to Tokyo and then all the way over. Wait, why didn't it just fly over here? It's much shorter. Because if you look at it, Auckland.
I just found a round trip to Buenos Aires and Johannesburg direct flight.
But I'm not saying it's not.
It's a Qantas flight, ain't it?
Yeah, there are direct flights, but this is the routes that they take, right? Qatar to Rome to Buenos Aires. This was the World Cup was here. They went to Rome to get fuel, and then they went down. Well, Qatar, Rome, Buenos Aires. It's a straight line.
But these aren't like you're showing me these lines on the map, but you're not showing me that if these are actual flights.
These are actual flights. You can, and I'll show you where you can document it all.
Yeah.
I'll show you the whole thing. So here, I don't show you that. Let's go here.
You got to put in time, bro. This ain't, this isn't something you could just get on a quick Zoom call and go, all right, like it, again, especially with information being censored, it takes time to find sources and ways to check things.
Yeah. So let's look at just a few emergency. What's that?
I mean, like you could find any flight by just looking it up.
Yeah, you can, but again, they don't always tell you the exact route that they're going. So here's an emergency landing that happened from New York. Right here, there's an emergency. They went like 1,000 miles out of the way to Seattle to emergency land rather than just land in California. But if you look at it, New York, Seattle, Hawaii, it's on a straight line. Because sometimes there's an emergency and they're like call control. They're like, all right, go here. So here's another one. And every time the emergency happens, this one, they went all the way to Moscow. It's a far distance right there, but they got there in an impossible amount of time. But if you look at it, Moscow's right on the flight route. Here's another one. They went to Moscow again from Doha, going to Chicago or vice versa, going from Chicago to Doha. And Moscow is right on the line every time. Well, they went to Calgary. Why? Because Calgary is right on the flight route every time.
Well, like I said, you have these lines and points on that map, but can you please show me where I can find these flights?
Absolutely,
specifically
at 100%. I will show you in 2 seconds. Here's one: Hong Kong. They were going to UK. Emergency stopped in Germany after 12 hours because 4 hours into the flight, the mother dies. Sitting next to the husband, little kids. They flew for 8 hours. Why? Because when it happened, they were over Russia. And they can't be over Russia, right? Because that wouldn't work out. And people would be like, why are you over Russia? And then someone would point out that there's a flat earth. And so they didn't land. They didn't land in Russia. And they made up some stupid excuse. That is absolutely it. So there is a book called 16 Emergency Landings that prove flat Earth. It's free PDF online, or you can actually buy the book if you want. Let me show you the book. And all of these emergency landings are documented, the news stories, the flight logs, everything. It's all been done for you. It's making it easy for you. You don't have to do it. It's been done for you. And it's beautifully put together. It's an amazing book. But just Google, it's actually on the app too, but if you just Google 16 Emergency Landings PDF, you can find the whole book, and then you can spend, as much time as you need going through it to document all of this stuff.
Well, can you tell me the source where it's getting these flights?
It's from? All documented. Everything's documented in the book. Everything's documented.
Okay. Yeah, then I'll look there. But I'd rather you I appreciate yeah, y'all are giving me this proof and whatever. But from what just from what you've shown me, it's been just lines and dots on paper that, yeah, they say this in a book, but I would like the source for where they're getting these flights, like, and
Yeah, I got it. So
like,
listen, you can go to the book. The book will have everything documented, all the news articles, the flights. You can look it up. You can double check it. It's going to take you a lot of time, but people don't want to take the time to figure things out like this. You say that we're just showing you lines and dots and stuff. I mean, we've done all the tests. Like, here is a lake, a frozen lake. We got a camera 6 inches off the lake. We put 4 lights 1 foot off the lake. This one is 8 miles, 7 miles, 6 miles, and 5 miles. And for some reason, they all show up on the same plane, when this one should be well over 30 feet, 22 feet, 15 feet, and 9 feet below a physical horizon. But for some reason, we can see them. There is no explanation.
What? Sorry, what were you?
The curvature math says that this light should actually be, I rounded way down, should be over 30 feet below a physical horizon. This one should be 22 feet, 50 feet. So this one,
impossible to see.
You wouldn't be able to see it. It's behind the ball. It's behind the physical curve. And so this one refracted up 30 feet. This one refracted up 22 feet. This one refracted up 15 feet. This ice here in the front refracted up 6 feet. You know, it's stupid. Like, everything refracts up to stop at your eye level. Why doesn't it refract up into the sky? There is no refraction.
Why doesn't it refract it? You know what?
Well, they're saying that everything can't refract to a level plane and then just go to refract. Well, I mean, these are all different. There's no uniform. You know, if these are all at different heights or different distances under the horizon, but they all come to be level, you know, it's taking out that
maybe
whole,
it's just
like,
level. Don't make it weird.
You know, that's the thing, dude, is you're asking questions about things, especially when it comes to some of the eclipses and stuff. Like, I'm not sure about you, but I haven't flown to the moon lately, right? So it's like, you can't, you're asking things that are just optical that can lie. You have to measure the earth, right? Curve, motion, you know, these are the things that prove if you're on a globe or not. You know, I could look up at a star and say, oh, I see a star, so, you know, we're on a plane, or we're, you know, that doesn't prove anything. That's not how science works. It's just saying, well, you know, we both saw an eclipse, so it has to be a sphere, or, well, you know, that's just not how it works when it comes to trying to prove stuff, you know.
Yep.
You know, for me, that's the equivalent of, you know, if you're saying you're a sphere, I'm like, well, go to Pluto. Oh, you can't. Well, it's like, all right, well, we're not a sphere. That, you know, that wouldn't be a correct way to prove that we're not a globe. You know what I mean?
Infrared photography helps us see things at incredible distances, where things should be miles and miles below the curve, and we can see that.
The curve.
Yeah, there is no curve,
like
anywhere.
Well, I mean, it's just very small to where we can't see it. But like I said, we can see that the sky around the North Star goes counterclockwise, and we could see that the sky around the Southern Cross goes clockwise. So hold
on a flat Earth, I'm looking towards the North Star, and the stars are going counterclockwise. They're going from my right shoulder to my left shoulder around. So I'm watching it's going counterclockwise. So all of this is turning, right? So all of the stars are coming from over here, over there. Now, if I turn around, they're no longer coming from my right shoulder to my left shoulder. They're coming over here. They're going clockwise now. They're going in the same direction. I just turned around. That's it.
So how does it go clockwise on a flat Earth?
I am on a flat Earth. I am on a flat Earth right now. I'll explain it again. All this, I'm looking at the North Star. It's over there. It's at 42 degrees off my floor. And all of the stars, all the lights in the ceiling, whatever, they're going around it counterclockwise. So they're making this big turn. I turn around. They're no longer coming from my right shoulder to my left shoulder. I turn around. They're going from my left shoulder to my right shoulder. They're going the same direction. I turned around. Clockwise is not a direction. East and west are directions.
You're talking about east and west and left to right, but I'm talking about counterclockwise and clockwise around a single point. So they're not going around a single point.
Again, the optics of the sky in a domed sky of vision. on the app on their southern star rotation. You know what? I think I could show you. Well, actually, I don't think we can. Under southern star rotation, we have it. This was made by a globe believer. Shows us how we see the sky, how we grid everything out in this azimuthal grid of vision, and he showed us how the stars will appear to spin. It works absolutely perfectly, but again, it's not something that you can just pick up on a quick Zoom call right here. You got to take the time and look into it.
Well, I'm just talking about
at the equator, they go straight. You know what I mean? On a time lapse, the stars aren't spinning anymore, right? Like if you go north, they're going clockwise. At the equator, they go equidistant, and then south, they're going this way. But they're all going the same direction. You're just changing your orientation of how you're looking at it.
Yeah, but that's at the equator. I'm talking about in the southern hemisphere, looking south. Well, and another thing, why can't everyone in the south see the Southern Cross if they look directly south? But that's another thing.
You can't. Nobody can see it at the same time. And when you're looking south, and you're in Santiago and you're looking at the Southern Cross, somebody in Australia can't see the Southern Cross because it's noon there. But 12 hours later, the stars will have rotated around and they can look at the Southern Cross now.
But but you don't need to go as far as Australia and Santiago. Like you could go any distant.
Do you know that the Southern Cross can be seen from the north? People have seen it from the north, and the North Star could be seen as far as 30 degrees. Not on a ball, it can't, but it has been documented. And the North Star has
been documented.
The North Star has been seen as far as 30 degrees south.
Where has this been documented?
Same with other constellations next to I'm not sure which one it was specific, but that one's seen as low as I think it was like 55, 60 degrees south, and those are northern constellations.
Right.
Where I'd like to know where this has been seen and documented, because as far as I know, nobody has ever seen.
That's where we can help you, but at the same time,
I mean, I want y'all to help me. I want y'all to show me
again.
Y'all are actively researching this field. I want y'all to show me in the northern hemisphere the Southern Cross.
You know what? I got to look that up. I saw the guy that actually did it. I have to find that video, but I'm going to definitely add that to the Southern Star Rotation playlist. And I forget the island that he was on. He documented the Southern Cross. I forget the name. I'll have to look that one up. I have to catalog that one.
I'm not sure if it was I think it was Austin. Was it Austin was the one that I just watched recently to talk about the Southern Crux, and he was showing the times and the directions they're looking. Yeah. Where when you saw Professor Dave's thing and they're all looking opposite directions, just showing, when in reality they're all looking somewhat towards each other and at different times. The Southern Cross is at a different orientation. It's not like you're seeing the same thing. It's all different perspectives.
It's right here. There's only 1 hour. There's only 1 hour a year where at these three locations you could see the Southern Cross at the same time. And then with magnetic declination, they all think they're looking dead south.
I'm sorry, this graph. So you just told me that Polaris never moves.
That's not earlier. Polaris. That's the Southern Cross.
Exactly. So, but if the Southern Cross is directly north at the north
not
pole,
north, it's south.
It's south.
Where do you think the Southern Cross is?
It is south, but this graph. So okay, sorry.
The north is at the center. The north is at the center of the flat Earth.
Yeah.
The North Star and south is every direction away from the center.
Okay. So why? Please explain this to me. Why is this the only time that everyone can see the Southern Cross?
At the same time. That's because they're in darkness at the same time. Because of the way I showed you how the light changes, you said the light is always 50-50. Well, that's not true. And that debunks the globe. The fact that there's 70% of the Earth is lit at some times and less than, that debunks the globe. But you are under the belief, which is a good belief, that it's always 50% of the globe is lit, because if the Earth was a globe, that's the only way it could be. But it's not. There's a problem. Something you're unwilling to address.
But this, you said, what do you mean I'm unwilling to address?
You're unwilling to
It is
accept the fact
it
that
is exactly 50% every single time. But this, you said it's that South is
Every year
everywhere
on July
away.
8th, 70% of the world has light. That's a fact, dude. Every single, it's impossible
they
on a globe.
announce it on the news. They announce it on the news every
Literally,
July 8th.
it's impossible if we're on a ball.
July 8th.
That July, they announce every
Every
year
on the news.
they announce that 70% of the Earth is lit up.
Yes.
And 90% of the population. Yes. I have multiple videos on TikTok about it.
Awesome. Great. I will look into that. But
and when you determine that it's right, are you gonna throw out the globe?
I will personally apologize to.
You don't have to apologize at all.
I don't need an apology.
I don't need an apology. You need to accept the fact that the implications of what that means. It means that your entire career choice is a bad one.
So I want to go into this little thing right here. So about the Southern Cross. Why is everyone looking at the Southern Cross above the North Pole?
It's not. You're seeing the perspective wrong. It's beyond this. It's way out south. It's way out south. So it's a two-dimensional drawing. It's hard to understand.
That's my
bad. It's above the blue guy.
Yeah. But this doesn't correlate with observation because it actually does. That's not south.
It does. It is south.
The reason why the Southern Cross is called the Southern Cross is because it is at the.
It's not the bottom cross; it's the Southern Cross. So it's still in the south on a flat Earth map. It's just the south.
What is the bottom? What is the bottom?
I'm going to show you. Let me show you. What you have to understand what directions are. So here's a magnet at the center of the flat Earth. It's the North Pole, and so my compass is pointing towards the north. Right, that needle's pointing towards the north. Now I'm trying to push this compass west. And I have to keep turning, correcting to the north to maintain a heading of 270 west. So I just circumnavigated, and now I'm going to go east. East, I have to keep turning because east isn't that way. East is around the circle because look, the compass keeps turning. Now, if I want to dead reckon west. So now I'm going to point that stick. That's west. And as soon as I start going, if I don't correct to the north, I'm heading south because the compass already turned. North is this way, south is this way. North is this way, south is this way. South is every direction away from the center. Now, if I head south on a globe, I should be able to go south and pop up over here. I should be able to go south from Santiago and end up in Australia. But if I go south, I'm never going to come back on a flat Earth. Guess what? Nobody's ever circumnavigated the Earth south, east and west. Now, if I'm going north, look, I'm going north. I'm going north. I'm going north. And as I pass the north, look, the compass just did a 180. Now I'm heading south. Even though I didn't change direction, every straight line is south.
And if you were to do the same thing south, it would.
What do you mean?
Go north. Like it would be the exact same thing, at least on a globe Earth. If you were to go south, and the reason why you said no one circumnavigated south because like Antarctica is just a big waste, like snowy wasteland. There's nothing there. Like
cool story. I mean, where'd you hear that from? The people that are controlling the world?
You know what? I heard it from NASA. They told me personally.
NASA, the ones that are faking space that I just showed you, just proved to you.
No, I'm just kidding.
Yeah, I know. I get it. I get it. But my point is, 0 people have circumnavigated south.
Billions.
Circumnavigated south.
No,
0
east to
people.
West.
East and west.
Oh, yeah.
Plenty of people have done it east to west, right? Amelia Earhart, you were taught about her. She circumnavigated the Earth. She just went around. This is east. She went east the whole way. East, and she came right around. You could walk around your neighborhood. Does that make it a sphere?
No.
It's a lake. If you drive it, you go around the lake. The lake's not a ball,
But at a lake, I would be turning. And
yes, you are turning, but the Earth is so large, you don't realize you're turning. Yeah. That's why
if you were on a track 500 miles around, you would think you were driving straight.
I'm sorry?
If you were on a track, a racetrack, 500 miles circumference, you would feel like you were driving straight. You would barely notice.
Yeah, but
okay,
you would still have to.
You would still have to turn. Absolutely. And check this out. You're going to say, well, pilots don't turn. Yes, they absolutely do. Because if the Earth is a globe, you still have to turn to maintain east and west. It's the same thing. If you were 1 mile from the North Pole and you wanted to head west, you have to keep turning. And then 6.28 miles later, you're going to be right back to where you started from if you maintain your heading of east or west. It's the same on a globe. The problem is south of the equator, you'd have to correct to the south on a globe, but that's not what happens. Many pilots, ship's captains, say when they're trying to dead reckon east or west in the southern oceans, they always have to correct to the north. That's flat Earth. They'd have to correct to the south if they were on a globe.
I'm sorry, who says this?
Well, reality says it.
Who is saying? Because you also just keep saying everyone is saying this. But
so we have documented from ship's captains, and again, you can watch the videos we've made, the testimony. You can go verify it yourself. But when any ship's captains that are in the Southern Ocean that are trying to dead reckon east and west, we have many whistleblowers from the military. They say that they are always correcting to the north. That is only works on a flat Earth. You have to correct to the north to maintain that circle. There is no southern south pole. If the Earth is a ball, a geodynamic ball, we have a North Pole and South Pole. Compasses would point to the south of the equator. Compasses wouldn't even work on the equator because they wouldn't know which way to point. But compasses only point north. Well, if you had a South Pole and a North Pole, they'd be contradicting each other about halfway through. But the thing is, compasses.
That's not how magnetism works.
Well,
that's not how it works.
Well, how come a compass doesn't point to the South Pole?
Because the North Pole. So I guess the
you're wrong.
The magnetic. I'm wrong. Wait.
By the way, you're wrong. Get a compass. Hold the North Pole towards the compass. It'll point towards it. Flip it over. It'll point towards that. It'll point towards the south end.
So if you know how magnets work, right? North Pole, South Pole, they attract. North Pole, they repel. Yeah. So the magnetic North Pole is actually in the south, and the magnetic South Pole is actually on the North Pole. It's just we call it the North and South Pole because
So the point is when you have
hold on. I'm answering your question about how the compass works. So if we have a magnet, and this is the magnetic the North Pole, which is also the magnetic South Pole, and this is the North Pole of the compass, it'll always, no matter what, it'll always point towards it, no matter what, no matter how far south you go, because if you go to the other side, this is still the North Pole. This is also the magnetic North Pole of the Earth, so it'll still be facing away. So it doesn't get confused. It's just how magnetism works.
A compass has the tip of a compass isn't magnetic. It's metal.
Yes, it is.
It's magnetic?
Isn't that how? I'm pretty sure that's
no.
How
it's just metal. It's just metal that is attracted
something
to
that is magnetic. Yeah,
it's not magnetic itself. Okay. So you can get a compass.
Still applies.
Absolutely not.
Still apply.
Absolutely not.
Absolutely not.
Get a compass and hold the South Pole of a magnet near it. It'll point to it. And then flip it over and it'll point to the other side of the compass. Compasses only point to the North Pole. And you made a comment. You said, no matter how far away, it'll still go. That's not true. Compasses don't work in Antarctica. They stop working.
Compasses don't work in Antarctica?
That's right.
Got it. So that just, I would love to see a source where a compass has not worked in Antarctica.
So go on on the frequently asked questions page, go to the Antarctica button, and there's video, a guy showing you that compasses don't work in Antarctica.
Okay, got it. So this I'm sorry, what'd you say about the compass and it not being magnetic? Because that's how compasses work. They are
Well, there's just a
magnetized.
floating. I don't think they're magnetic. Are they magnetized, Mike?
I don't think so.
I don't think so. There's just a little bit of metal on the end because
Like,
if they're
my piece
magnetized,
of metal in my hand.
Yeah.
if they were magnetized,
Is
they
it
would point towards a piece of metal. They would be attracted somewhere. They're just
So,
they're
shoot,
metal.
hold on. Something popped up on my screen. Oh my gosh. Hold on, sorry.
We got like 5 minutes. You got to. So any final
Okay.
questions you have, let's get to it.
So I'm not, maybe magnetic wasn't the right word. I'm not exactly sure how it works, but that's not, if
We are.
oh, you are? Okay. Yeah. All right.
We've done the work. We've checked. You haven't.
Mhm. And that's why I want y'all to show me this research that y'all have done. This was my whole point of coming on here, so y'all could show me your research.
I got it. So again, and I don't expect you to believe a video, but on the app, on the frequently asked questions page, all of the questions, like you want to learn about Antarctica, hit the Antarctica button right here. And there's tons of videos, the compass videos there, the no midnight sun, all of the stuff. You want to learn about, boats over the horizon, click the boats over the horizon button, ships over the horizon right up here. You want to figure out why the lie? All the stuff is answered right here. It's all being hidden from you. And so here's a resource. I don't have 50 hours to give you, but I'm giving you all of the resources that you need to find this out yourself. I can't handhold you through it. We've been on for 2.5 hours. So, we've given you as much as I can. I've showed you that NASA lies. I've showed you that eclipses prove that it's not the Earth. I've showed you that there is no curvature. I've showed you that the sun doesn't light up half the Earth, but in your world it has to. But when you find out that it doesn't, I don't think you're going to give up the ball. I think you're going to come up with an excuse, and then you're going to move forward because, this is an emotional, rough topic for somebody that wants to go into astronomy.
Yeah,
it is what it is, man. And that's where, again, with a lot of this, you're going to find that, like on the app, there's a lot of people who have done experiments, right? So you're going to have to also at times do those yourself, right? Like if he gives you numbers and someone has said that this experiment worked, well, now you do it. If it works, then you can say, yes, okay, this is something that I got your numbers. I have your theory. I'm now implementing it in reality. And I either get what you got or I didn't. And then we explain and talk about why we didn't get our stuff. Because again,
so then why does the equation for gravity that I have said works, why have y'all proven that doesn't work then?
Well, so I told you about electrostatics and
I'd love to get.
Well, no, I told you about it. And again, the gravity button had tons of information on there that'll show you that. But the thing is, did you know that things fall at a different rate during electrical storms? Why is that? Why don't they do?
They don't.
You're wrong. You're wrong.
So why
You're wrong. Did you check?
So I didn't feel the force of gravity increase on me, and I didn't
I'm saying
see any
during
of the
electrical storms,
computer
during electrical storms.
Right?
Hey, George.
Sorry.
You're just defending a position that you know nothing about. During electrical storms, things have been measured to fall at different rates. When lightning strikes next to somebody, they usually get thrown in the air. What happened to gravity? Or did we just change the electric potential of the Earth? We can demonstrate.
What do you mean, what happened to gravity?
What happened to gravity?
If someone gets flung in the air, that means that a force is being exerted.
100% an electrostatic force. Correct.
Electrostatic force? No.
Did we not talk about electrostatics? Didn't we go over?
No, we did not. But I would love to.
We didn't do that?
No.
Not well. No.
We didn't do it. Didn't we do the balloon? Or am I thinking of a previous podcast?
Nope. That was previous. You didn't do that on this.
All right, George, we're gonna do that real quick. Wow.
Okay.
I thought I didn't show you the silent drone, the whole thing. God, too many today. All right, so
wait, a drone? I'm actually
hold on. So
yeah.
down is down here. You know, if we want to we say down is down. You know, Globe says down is in all these different directions, which is just weird. So I showed the three body problem, but here is an experiment, a little experiment we did. So we have some leftover party balloons, and we tied them to this, just a button that's on this wire that goes to a Van de Graaff generator, and it's neutrally buoyant, like 2 inches off the floor. It's just sitting there. So we're going to add a positive charge to the button. And as we crank up the generator, it goes down. Now, did we make it heavier, or do we make its attraction to the negatively charged Earth more attractive? We discharge it, it goes back up. So did we just change gravity, or did we change electrostatics? What's the opposite of that? So here is a.
Sorry, what'd you say was happening?
So we're adding a positive charge. We're making it more positive charge. The Earth has a negative charge to it. Everything in the air is positively charged. Negative and positives attract each other. The Earth isn't moving. So when you have something that's positively charged, it will be attracted to the Earth. Buoyancy and density sort everything else out. Now, this force, this electrostatic force, is a very weak force, but I'm going to show you how weak it is. Okay. And so when we discharge it, when we charge it up, it goes down. And when we discharge it, it goes back up. What's the opposite of this? We can add a negative charge to something, and it goes up. Turn it off, it goes down. If we add a negative charge and we keep it in, it'll stay up. Now, are we defying gravity, George, or are we defying electrostatics?
Nope, that is, yeah. So
I'm not done.
Bulk. Okay, yeah.
I'm not done. This is done by MIT. This is called the silent drone. And there's no moving parts, and it flies. All they're doing is changing the electrostatic force of it. They say it's the ionic wind.
I've never seen this.
Yeah. They say it's the ionic wind that makes it fly. There's no moving parts. It's just a negatively charged, and it's pulling. If it could pull, imagine if this could pull energy just out of the air, which it could, then it would never need to charge. Wouldn't that be amazing? Go ahead.
Yeah. So the specific thing that I want to do, I want to be an electrical engineer, but like I want to go into the field of astronomy also. And I actually really like drones, and I have studied this specific one.
Yeah.
And I know exactly how it works. So it uses, can you go back to the video real quick?
Yep.
So that it uses a stacked grid of electrodes to knock off electrons from the oxygen and nitrogen around it. And it ionizes the air around it, and then it discharges that to.
What about gravity?
What about gravity? What do you mean?
It's changing its electrostatic potential. That's all it's doing. It's not flowing air down.
A force greater than the force of gravity.
What force is
upwards.
that?
So, what force is that?
Go ahead, Mike.
It's just it upward. Sorry. Yeah.
Well, I was just going to say, well, that's the point. The electric potential of Earth is a stronger force than gravity is measured at. So that's where the whole electrostatics, when we're talking about something pulling down, why would you think it's something that's weaker than the force that we can prove?
And do you know how much weaker they say gravity is? They say the electrostatic force is 10 to the 26 power stronger than gravity. 10 to the 26. Right?
Cool.
10 to the 26. You know what that means? That means gravity has zero force. Zero.
Cool. So why do metal objects not fall faster than electrically neutral objects?
What are you talking about?
Like us. See, we are neutrally charged. Bulk matter is neutrally charged. That's what I was getting at earlier.
Metal falls faster than things that are lighter than metal.
They don't.
They
do not. Everything falls.
All right, you have to understand.
No,
well, they don't, because that's an agreed upon median. That's not.
But I've actually tested this in my physics class. I have seen this and tested this for myself. So if it's heavier, or no matter what it's made of, it falls at the exact same rate, 9.8 meters per second squared.
Wrong.
That's an agreed upon.
Wrong.
It's an average.
An average?
And something. So you're saying a pound of metal falls at the same rate as a pound of balsa wood?
Well, they're both a pound. So even if what you're trying to say is that heavier things fall faster, they fall at the same rate.
You're wrong. Okay, you got to go do a test.
I've done tests for myself.
There's 0% chance that a pound of balsa wood falls at the same rate as a pound of metal.
It's
0.
true.
It's not true.
I've done
You're
the
wrong.
experiment for myself.
You're wrong.
I derived the equation.
Yeah, maybe you did it in math, but in reality,
in physics.
Did you actually drop them out of a window?
Did I actually drop them out of a window?
Yeah.
No, but the results would have been the same.
Well, no, you did it on paper, and you didn't actually do the physical experiment?
I didn't do it on paper. I dropped the objects. We timed how long it took, and they all came up at about 9.8 meters per second squared.
Good luck with that.
Good luck with that. All right, man.
Yeah, there's plenty of experiments that have shown the actual opposite of that.
Yeah, where are those experiments?
Look them up. I can't hold your hand on all of this.
All right, dude. Great. It was thank you so much for your input on that.
All right. Good luck on your career choice.
Good luck on my career choice.
Look, keep researching though, man. Seriously, because you're on the right path, bro. You like space, you like astrology, whatever you want to call it, astronomy, astrology. You like it. You like electrostatic.
Same thing.
Exactly. And those are the things that matter, dude. Keep looking into it and just understand that what we're trying to do is just get you to understand that things are not just what you've been told, and not everybody agrees that everything's just like, no, it's not true. There are a lot of people doing a lot of good work. Just look at it. And again, you have to do your own research with that, your own experiments, or otherwise you're just believing some guy doing a video on YouTube. You have to, it's something where you do have to definitely implement unbiasedly information and do it yourself.
When I first came upon this, I thought it was stupid. And then I bought $1,000 super zoom camera, and I started zooming in on things that should have been hidden behind the curve. That's what did it for me.
So yeah, going back to the entire reason why I'm here, and you say do your own experiments. I wanted to see your experiments for this. Yeah. that y'all have done. I have done experiments.
They're all on all those playlists on the app.
Okay, so then why can't you give me specific things like numbers and flights like the Globe Earth can?
I can. I did the book. If you want the numbers and the flights, it's all in the book. It's all documented. You want me to read the book to you?
No, that's all right.
All right, George. Good luck, my friend.
Good luck to you too. It was great being on here.
All right,
have a good one, brother.
Bye.
Y'all too.
Bye.
He's a nice kid, dude. He's a nice kid.
But
he's a nice kid.
What are we gonna do? Do? That's the future of America, man.
Yeah, it's tough, dude. I know, man. I'm like, dude, I can't be. It's hard to be rough with him too, because again, he's a nice kid. I could tell he's a genuine.
I had you because I would have chopped his head off a half an hour ago.
I know. Oh, I know you would have, dude. It's hard for me to do it, man. It's hard if the guys are nice. It's hard.
Yeah, no, I needed to be nicer. I was getting a little pissed off.
I know, but you do this a lot, dude. So I get it. You're saying this. It's easy to see, man. When you're speaking something, especially when they're not idiots, and then it's like this is common sense. You're already, if you're getting some of this stuff, how are you not getting this? It doesn't. It is frustrating.
His whole thing with the Earth is only half lit. Yeah, that's something you need to believe if you believe in the globe. But then when you find out it's not, what do you do with that information? You go, whoa, what do you say? Refraction and gravity? Gravifaction.
And if you notice, we had to bring it up twice. Like we had talked about it, and then literally within 15 minutes, he was like, "Well, what do you mean 70% of the world gets it?" It's like, well, brother, we just said, that's the thing. It's like, it's so much information. I think they just get put in a fucking blender, and now they're just, like you said, they're just defensive. Fucking, they don't even know what's going on. Yeah. You could tell, man. He was spinning, dude. He's thinking, dude. He's thinking hard.
I hope so. I hope so.
Man, he did okay.
All right, man. This was fun. Let's do a TikTok soon.
Oh yeah, 100%.
Live. Let me know when.
All right, brother. Hey, have a good one.
Thanks, man. See ya.